Hello everyone. Good afternoon to all of you. This is Subha. Hope my voice is clear and audible to all of you.
Yes, sir.
Yes, sir.
Good afternoon.
Good afternoon, Priyansu. So today's session on week 2 and written to be as an open session. So we can go with as like if you want. This is like open session, doubt session, and for that I have one slides also. There I have written some questions from activity only, and with some key points I have written, which I have taken from solve with assignment. If you have conceptual doubt or what is the process to find the row echelon form, reduced row echelon form, so that we will discuss, and Gauss elimination also. And the last session taken by Susmita, and approximately lecture three lectures she have completed, I think so.
Yeah.
So I have one doubt
Okay.
regarding a concept. Like when we use row echelon form, how do we decide whether the system of equations have unique solution, no solution, or infinitely many solutions? Right, sir, there are activity questions. For example, in 2.6, activity 2.6, question number 5, 6, 7, and 9. They are related to this concept.
Okay. What is that regarding when you are using the row echelon form? Then
How do we decide whether the system of equations has a unique solution, no solution, and infinitely many solutions?
okay. 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 So
So in both cases, whether the system is homogeneous and when the system is not homogeneous.
Okay. Let me see screen first. So this is what I have.
Sir, I have a doubt in practice assignment, sir.
Okay. Okay. So yeah, just a minute. So yeah, I will discuss your doubt with this. This is how to when a system of linear equation has unique solution, no solution, with this example. Okay. I have written this one. Yeah, I think this is from activity which you are saying. I think same activity.
Okay.
Yeah. So, so let me take. You can raise your hand. Like you can raise your hand as you want. Then I will be back to this slide. Let's finish this first. This whatever you have doubt quickly. Then I will be back to this slide.
So can you just explain Gaussian elimination once?
Okay. Yeah, sure. So just 1 minute. Let me finish this doubts, whatever we have. Like Biswajit is want to ask from where, Biswajit?
Yes, sir. Sir, actually, I didn't get the concept from lecture. So.
Okay. And okay.
Yes,
Sridhar, your specific doubt from activity or
Practice assignment, sir.
Which question number?
Sir, question number 6. Sir, yes, I have solved this question, sir, and got the correct answer. But I want to know how will you solve this question, sir? Because my approach is I haven't used the concept that was taught in this lecture, sir.
Okay, so let's see. How did you solve this?
Sir, first of all, I wrote how much protein, carbohydrate, and fat there are in one banana, and half mozzarella and one avocado. And
This is not question 6. Question 6, right?
yeah, question. Sir, there are different sets of questions.
Okay.
A gym trainer suggested transal to include banana, mozzarella. Do you have this question, sir?
Okay, just 1 minute. This is from practice assignment. Okay.
Practice assignment 2.
Practice assignment. Sorry, this is one. Sorry. Yeah, that's question number 6. Yeah, okay.
Yes,
okay.
sir.
So
can I tell? Yes, sir. Then I wrote how much protein, carbohydrate, and fat gym trainer has suggested. Then how much calorie from one banana and half mozzarella and one avocado we get.
Okay.
Then after I looked at, I have to make protein 18, one banana 10, half mozzarella 1, and one avocado 3. So I took half mozzarella.
Okay.
So one mozzarella, 2 protein, 12 protein, and two avocado, 3 into 6. So 18 protein. So one banana, one mozzarella, and 2 avocado. And in this way, one banana, 105 calories, one mozzarella, half 90 calories. So I take half more than 180, and 2 avocado, 230. In this way, I get 515.
515.
Yes, sir. And this is the correct answer, sir. But how will you solve this question, sir? By using the concepts?
Actually, the purpose of this question is first form the system of linear equation, then use the Cramer's rule.
Cramer's rule?
Yeah. So to form the system of linear equation, like you have to assume what is the question here? In one banana, 10 unit protein, 50 unit of carbohydrate, and 0 unit of fat, and like that in half cup mozzarella.
Yes, sir.
Mozzarella and rest in avocado. So what is that? Suppose the calories intake from one banana this much. If the gene trainer suggested Ponjel to take this much protein, carbohydrate, and fat, so like you have to take you have to make a system of linear equation. You have to assume what?
Sir, can you please make the equation, sir?
Okay, you mean to say this is the result, right? 110 units of carbohydrates, 20 units, 22 units of fat. 3 components should equal to 110, right?
Yes.
Sir, one thing I want to ask. So while solving this system of equations, how do we decide that we have to use the Cramer's rule or we have to use inverse of a matrix?
Yes.
And when we have to use the row echelon form?
So actually, Cramer's rule is like you have a system of linear equation in this form, like your coefficient matrix. Suppose this is the system of linear equation, and when your system of the coefficient matrix of your system of linear equation is a square matrix, and the determinant of this matrix is non-zero, because the Cramer rule says determinant of a.
Yes, we have to use it in denominator and it should not be 0.
So this should not equal to 0. And determinant is working here, so that means your coefficient matrix should be square matrix. Then we are able to apply the Cramer rule. Suppose you have a system of linear equation such that your coefficient matrix is not a square matrix. So in that case, how you will find the determinant of it?
No, we cannot.
Sir, but if we know the reduced row echelon form, then why we will use the Cramer's
So
rule.
it's totally up to you. See,
Yeah.
these
Yes,
are
sir.
the
When the matrix is not a square matrix, then the only option left is row echelon form, right?
row echelon form or Gauss elimination. That is called Gauss elimination method.
Yes,
Yes.
Gaussian elimination is a kind of extension to row echelon form.
Gauss elimination is just extension, you can say. That is a method.
Got it, sir.
Changing to
Got it.
this coefficient matrix in reduced row echelon form or row echelon form. So
Out of Cramer's rule and using the inverse of a matrix, we can use any of the procedures because both are valid for a square matrix.
So in one word, if I will say a system, if a system of linear equation has unique solution, in that case only you will use inverse method and Cramer rule. That's all, because
Yes, sir.
inverse
Yes,
method
sir.
will
That's
give
why
unique solution. Cramer rule will
Okay.
give unique solution. But suppose there is a case that the system of linear equation no solution or infinitely many
Yes, sir.
solutions.
How do we find out that whether the system has that's what I was asking in the beginning, right? How do we know whether the system is having unique solution, no solution, or infinitely many solutions, both for homogeneous and non-homogeneous systems?
Non-homogeneous or both homogeneous, non-homogeneous in any case.
Yes, sir. Please kindly, sir, I'm confused in this topic, and I would be thankful if you could clear my doubt.
So also, what is a augmented matrix? Like augmented matrix, can you just explain that?
Okay.
Sir, is this a continuation to the yesterday's lecture? Because till yesterday we completed till lecture 3.
You can think as a continuation. Yeah.
So then I would suggest that first we go through the concepts and then we take the question.
Sure. So yeah, while discussing the this final thing, Gauss elimination, we did discuss the row echelon reduced row itself. So let's the final thing discuss, because I'm looking so many many of you have the doubt in Gauss elimination, no solution, infinitely many solution, or unique solution.
Yes,
and for
yes.
this question, this whatever this Gauss this Jim Trainer question.
Yeah.
So
Yes.
for this question, you need to find a system of linear equation. How you will assume how you will form a system of linear equation with this context. So in this question, see, in this question you don't have how much this we want a quantity of one banana. See, it is given for one banana for 1/2 modulo cheese, like mozzarella cheese, and for one avocado is given, and the trainer is suggested to consume trainer is suggested to consume 18 unit of protein, 110 unit of carbohydrate, so and 22 unit of fat. So how we will form the system of linear equation?
Can we do like this? Like the first equation would be the total proteins in all these three items of three items of food. Second one would be for carbs, and then for fats.
I can explain.
Can we do that? There'll be three equations: one for protein, that these many, but
see that I want taking this first one 18. Trainer suggested Panjal to take 18 unit protein. So how we will get 18 unit protein? One banana
10,
have only
10 into number of bananas. 10 into number of bananas.
Number of bananas. You have to assume, suppose X number of bananas are there.
Yes.
Y number of 1/2 mozzarella cheese, and Z number of avocado. Then you can change it to be like to form a system of linear equation, because it is given in one only. It is given for one. We want 18 unit of protein. So how we will form? If you add this one for one banana, you are getting 10. Okay. For 1/2, you are getting 1 protein, and for one avocado, you are getting 3 unit protein. So how we will get 18? So you have to assume I need to take, let's say, X number of bananas.
Sir,
into 10.
I think, sir, there should be columns of protein, columns of carbohydrates, and columns of fats.
So and like that, so let's make a, if we want this table, so suppose this is fat, this is Oh, this is protein. Protein. This is next is carbohydrate, and next one is fat.
Sir, wouldn't it be better if we took that in rows? Because then we have the total protein, we have the total carbohydrates, we have the total fat.
Okay.
So that would be our B.
Okay,
Sir,
okay.
Sir, in this way we can also take, sir. Suppose we are taking.
Okay, let's take a different way. Okay. This is carbohydrate. This is next one.
Yeah.
Is
Fat.
so one banana, whatever 10. Can you tell me what is that? One by one. In one banana, we are getting 10 unit protein, 3 unit something. What is that?
10, 50, and 0.
10,
50.
And 0. And next one in one,
50,
this is banana.
Sir, 50, sir, not 15, 50. Yes, sir.
This is banana. Next one is
half
1 by 2.
Yes, sir.
Mozzarella. Okay. So in this
1, 20, 1.
And next one is
3, 10, 10.
3,
1 avocado.
10, which is avocado.
Yes.
So assume that so now I said I want to 18. The trainer suggested you want 18, but if you add, this is 14 only. So how much? See, then you need to take some bananas, some more bananas, or more the mozzarella cheese or avocado. So assume that I need X number of bananas, Y number of mozzarella cheese, and Z number of avocado. Okay. So
Yes,
suppose I assumed one X number of bananas. So total protein will be 10x. Okay. And carbohydrate will be 50x, and fat will be still 0. Similarly, here it will be y. This will be 20y, and this will be y. And the next one is it will be 3z. It will be 10z, and this is 10z. Okay.
yes,
This much after assuming this number of items, we will consume this protein, this carbohydrate, and this much fat. And trainer suggested this protein should be 18. So that means this column is protein, this column is carbohydrate, this column is fat. So this should be 18, and this should be how much? 110. And this should be the carbohydrate, total carbohydrate should be total carbohydrate should be 110,
yes.
And fat should be 22. So this is after assuming that, okay, let's assume X number of bananas, Y number of cheese, and Z number of avocado gives us 18 unit of protein, 110 on a unit of carbohydrate, and this much it gives. Now you have a system of linear equation. This is just for in this.
And now we can use the Cramer rules, sir.
Plus y plus 3z is equal to 80. 50x plus 20y plus 10z is equal to 110.
So this half won't make any difference.
So this half is only just a multiple of half cup. Like if suppose it will not be like a half is not here is not, it will not into well help any number. It's just a half saying to be half cup.
Okay, because we are only dealing with protein and carbohydrate. Okay.
And the next one, this will be y plus 10z is equal to 2, 2. Now we have system of linear equation. The coefficient matrix will be 10, 1, 3, 50, 21, 10, I think. This is 10. Okay, and this is 1. This will be 0. This will be 1, and this will be 10. This is our coefficient matrix. Find the determinant of this. Okay, this is, and the next one is replace the first column with this B column. This is called, let's say, this coefficient A. Yeah.
Excuse me, sir.
Yeah.
A12 should be half, no?
A12. Oh, okay. A1.
A12.
A12.
10, half, and 3. It should be 10, half, and 3, no?
No. Why this is half? This is 1. In half, that's why you need not to assume this half. This is just saying to be half cup. It will not work as a number.
We are using protein And
Sir, I think at the end, whenever we get the number of that y,
We have to divide it by 2.
we can,
Suppose
yes,
no.
yes,
Suppose you got the number of whatever you got y number. That is the
yes,
number of half cup mozzarella cheese. That is the
yes,
number
sir,
of half
exactly.
cup mozzarella cheese. That's all. It will. There is no use of this half word. Half is. It will not work as a number here in any equation. This is just for the. You have a cup, half cup, and this much half cups cheeses we want. That's all. So that's why half cup gives 1 unit protein. So it will not here half. This one we needed. Half cup give 1 unit protein. Okay. So now for x, so for value of x, we need determinant of the matrix, which is replaced. This column is replaced by this portion, this right side B. This is called B. Ax is equal to B.
Sir, actually, this Cramer's rule is discussed yesterday. Can we move to echelon and Gaussian?
So actually, just I want to be yeah, okay, fine. So actually, he wanted to ask this system of linear equation
yes,
how.
yes, sir. I have.
Sir, can you show the matrix
I
once
have
again?
2 more doubts.
Let us discuss. How do you know this system is having a unique solution?
So unique solution, when you evaluate this determinant, it will be it is not equal to 0, and in that case you have a unique solution, which will be next when you come to in Gauss elimination. It will tell you okay what's happening. Or see, there are condition taught in video lecture also. When we apply the Cramer's rule, the Cramer's rule will be only applied when the coefficient matrix have means the determinant of the coefficient matrix is non-zero in such case.
Sir, sir, I have 2 more doubts.
There is, sir, whether the system is a homogeneous or non-homogeneous, it doesn't matter, right?
It
In
doesn't
both the cases,
only
it has-
needed to this coefficient matrix should be square and determinant should be non-zero.
and
Okay.
we are going to get a unique solution.
Unique solution.
So, could you just explain
got it,
homogeneous
got
and
the
those
difference.
stuff also once?
Okay.
So here
If the
I have
matrix
one
is
question.
invertible, you will get the unique solution.
So here, not particular to this question, I have one silly doubt. Can I ask?
Yeah.
Yeah, we have these type of equations, 3 linear equations or 4 linear equations. whatever it is. Now we are writing, we will take this as an example. We are writing 10, 50, 0. Okay. So we are going vertical. 10, 50, 0 vertical. That is column we are writing. Next is 120 something 0.
Okay.
121. Okay. We are again going the column wise. Then 3, 10, 10 we are going. So we are column wise. So A, when it comes to coefficient, we are going column wise.
No. Actually, we see that's why I want to. We just wrote over the whole information in this form. That's why we are going to column wise. Suppose we wrote this information is like this.
Oh.
Yes,
Then it will be like row wise, right? There is no effect. So actually, we want the whole thing. The main concept is this protein unit should be added to it. That's all.
No, because we are going some cases we are going column wise, and when it comes to x, y, z, the row wise we are like a transpose, we are changing it to column, and then for B is again column wise we are just writing. When we write, no. See.
No. So see, there is no like I will say there is.
Sir, you got my doubt, sir.
Like in different case, like in higher, then it will be effect row or column, but there is no relation with the row and column. Just needed to form a system of linear equation. How you are managing that? However, you are writing. See, if I want to
write,
write like
we are not writing x, y, z in rows, sir. That is my doubt. Okay, you are writing. Okay, A coefficient you are writing in a tabular form, in a matrix form, but x, y, z is always it is unique, only one column, right?
Not only one column. See, I am not doing anything. What I am saying, unit proteins should be added to 18 units. So I will add only proteins from x number of bananas, y number of 1/2 mozzarella.
Okay.
There is
that is correct, sir. That is B, sir. That Ax equals B, you are doing it. 18, 110, 22, you are doing it. That is B. X, when Ax equals B, we are writing. No, A is the coefficient, we are writing it like this. When it comes to X, why always we write it X, Y, Z in column wise? Why we are not writing it in row wise?
So that is what I'm saying. I have chosen this form. That's why I just wrote it. See, there is no column and row. First, let me tell you, there is no column and row. First, forget about that. We want to find a system of linear equation. Okay. I assumed X number of bananas, Y number of mozzarella cheese, and Z number of avocado will fulfill our requirement. Okay. So now X number of bananas, how much protein will give? 10x. Okay. 10x unit will protein give. Similarly, this carbohydrate will give 15 unit. Yeah, or let's forget carbohydrate. 10 unit of X number of banana will give 10x unit protein. Y number of what is that?
No, sir. That one clear. Last one. Last. I just conclude, sir. I won't drag this.
Sir,
now
can I answer this question?
Yeah. We have 3 by 3 matrix as A, but when we write the X, we are writing it as 3 by 1 matrix. But if we interchange it, it will become 1 by 3, which we cannot do the multiplication.
Exactly. Yes. That is the answer for your silly question.
No, that is correct. But if I do it in the other way, no, what Shubham?
Sir, you cannot multiply, no, sir, because the column and rows are not equal, no. So the multiplication cannot be done in that way, right?
But here it is okay. 3 by 3 we got nicely. But another one, some another one is there. 4 by 3 on the
If 4 by 3, then we will not apply Cramer's rule.
Okay. Cramer's rule, but okay, Ax equals B. Okay, that's fine, sir. We will move on.
Just take your time. You will slowly see.
Okay,
you will get that. That's all. My mean is there is no forming the system of linear. There is no row and column thing. Forming the system of linear. According to our context, we are just going. There is not use of this one. According to just our information, we form this table. Otherwise, there is no use of it. We are not going row column wise. Only our information we are using that.
Okay, sir. We will proceed, sir.
Okay. And homogeneous system of linear equation and non-homogeneous system of linear equation is. See, if you have a system of linear equation like this, suppose ax plus by. Cz is equal to 0. All the right side of how many number of equations are there, each equations, the right side of each equation is 0. In that case, the system of linear equation is called homogeneous. Suppose this is the system of linear equation, the right side is 0. How many numbers of it is not, it doesn't matter, but the right side should be equal to 0. If any one of them is non-zero, then that system of linear equation is called non-homogeneous system of linear equation. Okay. And suppose your system of linear equation is the coefficient of system. Say suppose your system of linear equation is homogeneous, and your coefficient matrix is, you are able to evaluate determinant of matrix, means your coefficient matrix is square matrix. In such case, you could directly say that the solution will be square matrix and determinant is non-zero. In that case, your solution is directly should be 0. How it's happen? See, because your system is, suppose you are able to find the coefficient matrix as a square matrix, and you evaluated the determinant of that matrix. Okay, and you got it is non-zero. So then in such case, solution will be what? X1 will be determinant of ax1 upon determinant of A, and ax1 is saying to what is ax1? Replacing the first column with the right side of the system of linear equation, that is column of, that is B called. And if you replace with the, see, all numbers are 0, you replace with the first column with 0, 0, 0, the determinant is 0. So that means 0 by determinant of non-zero determinant of A, which is 0. So it will apply the two whole, this one, all will be 0 upon non-zero number, which is determinant of A. The third one is also 0 upon determinant of the coefficient. So all will imply 0. So homogeneous system of linear equation if you are able, your coefficient matrix, determinant of coefficient matrix is non-zero, then you have a unique solution which is only zero solution, 0, whatever you will say. And if suppose your non-zero number, so each time you have to evaluate the numerator determinant, which is determinant of matrix replaced by the corresponding column, you can say. Hope you know the from video lecture, and yesterday the lecture you have also deal with the Cramer rule. So in differently you will get the non-zero number or zero number, whatever the numerator number will come, divide with the denominator, divide with the determinant of coefficient matrix and get the answer. That's it.
Sir, in such case, if determinant of A is 0, then will it have infinitely many solutions?
So no, so when determinant is 0, so you will not apply Cramer rule, you will not apply inverse method. Only the remaining thing is Gaussian elimination.
Okay.
Because in that case, the system has, see, if the determinant of the coefficient matrix is 0, so you will surely see, then you can sure that the system has either no solution or infinitely many solutions if determinant is non-zero. Okay, sorry, determinant is 0. Sorry, determinant is 0 of coefficient, determinant of coefficient matrix is 0. Then the only option is remain either the system has no solution or infinitely many solutions. There is no concept of then no concept will not come for unique solution.
Sir, can you give the example of the case when there is an infinite solution when determinant is equal to 0?
So let me
one doubt. When the determinant is 0, the only method which is going to tell us whether the system of equations is having a no solution or infinite solution.
Infinitely many solutions.
Gauss elimination method, right?
Gauss elimination method will only help in such case.
Okay. Now I got it.
Okay, so let's move to let's finish this Gauss elimination.
One more thing, sir.
So discuss the concept from the beginning and quickly, and then we can.
So I just had one doubt in row reduction. So whenever we have to convert it into an echelon form or using row reduction, so is there any particular order that we need to follow, or it's okay to after making the first column 1 0 0, then we can follow any order? Is it so like that?
So let's first clear the doubt of the homogeneous, please, before we go on.
Homogeneous is done, right? Homogeneous.
Also, I have a doubt.
Okay, what is that?
Sir, in case the system is homogeneous, is a homogeneous system, then it has infinite many solution if determinant is 0 as per the lecture.
As for the lecture,
but you said that no solution also.
No solution. Why I mean to say, I just refer to the Gauss elimination. Otherwise, okay, you can say if for the homogeneous case, if the determinant is non-zero, then you can directly refer to the infinitely many solution. All things will be concluded with the Gauss elimination. Everything is concluded with the Gauss.
No, so just to clarify, if the determinant is non-zero, then we have a unique solution, and if the
which is 0 for the homogeneous, if determinant is not 0, then unique solution, which is the 0 solution.
And if 0,
if determinant of the coefficient matrix is 0, your system is homogeneous, then in such case you have infinitely many solutions, and all things will be determined with the Gauss elimination. See, I will say many times always use Gauss elimination. No need to use of this Cramer or inverse. That is a method.
Sir, and if the system of linear equation is non-homogeneous and determinant is equal to 0, then no solution.
So no. So then case is different. Then either no solution or infinitely.
Yeah, sir. When will be the infinitely many solutions?
So that is the Gauss elimination only decide. You after doing the reduced row echelon form, changing the augmented matrix in row echelon form.
If the coefficient matrix is non-square matrix, then there is a case of infinitely many solutions. And suppose if there is a square matrix and determinant is 0, then there is a no solution. Am I right or wrong, sir?
No. So let me conclude. Okay. I didn't listen properly, I think so. So see, so don't be confused. Don't with the directly say to okay, no solution, if I solution. Not such cases. When you will only we will conclude these all things using Gauss elimination. Let me finish that. Then
okay, sir.
all doubts will be clear. Everything will be clear.
Yes, sir.
And one girls have asked about this leading one. So see, when you changing the row echelon form to sorry, matrix in row echelon or reduced row echelon form, the best way is like if you are not using, if you are making one to any any different from the row, that is called different from row one. So it will be difficult to making zero, and the condition is also reduced row echelon form or reduced row echelon form is you make it, you have the first row should be one, and the next row non-zero number will come right side, which should be one. So you will follow. That means, I mean to say, when you are very much exercise, you have done very like so many questions, you have practiced so much, you can automatically know that okay, we need to change where I need to do all things or not. But in starting, if you follow whatever in this whatever the process told, that would be better. Otherwise you may confuse. But when you do many practice, when you do more question,
Sir, but I just had like what is actually expected? There has to be 1 0 0. Then we in the place of the second row and the second column we have 1. So what about the rest of the elements?
so rest of okay, let me explain with the example. I am going now again.
Yes,
Gauss
sir.
elimination will everything. It will we have to be Gauss elimination work on reduce or row echelon form. So let's do with that with an example. No
Yes,
solution,
sir.
definitely many solution which I have taken here. All the numbers after changing this CED will change when we have system of linear equation is no solution, infinitely many. Let's do this one. Everything will be finalized. So we have a system of linear equation, this one. So augmented matrix and coefficient matrix. The coefficient matrix of this system of linear equation is this one, 1, 2, and this is 2, 1, minus 2, this is 0, 3, and C. So this matrix is coefficient matrix, and augmented matrix is minus 1, 1, 2. You will include this. You can right side will differ with this vertical line. You can say this is called augmented matrix. Right, this right side of the each equation is with the right side of the line, and this is 2. This is 1. This is minus 2, and this is minus 1, and this is 0, 3, C, D. So this is the augmented matrix. And this is the coefficient matrix.
So you're bringing in the D inside the coefficient matrix. That is augmented.
If you include with the right side of the vertical line, write the B term, this B column matrix B, then it is augmented matrix. Okay. Now we want to see each option is given when C is equal to 2, D equal to 1, the system has infinitely many solution or no solution or unique solution. So let's change these number with okay, this is minus 1, 1. Let's take the first option. One case I want to say, suppose your this right side is whole, this is means to be 0. This right side is 0. So there is no need to write the augmented matrix, right? Because this whole thing is 0. Only need to apply this coefficient matrix. Whatever the operations you are going to do, only need to apply on the coefficient matrix. There is no need to write this 0, 0, 0 if your all right side is 0. Okay. So in such case, you no need to write this right side of the line. Only work on the same thing. Whatever now we are going to do, same all process you need to do with the coefficient matrix only. Okay. So this is minus 1. This is 1. This is 2, 1, minus 2, minus 1, 0, 3. Now I am taking the first option. C is 2 here and D is 1 here. So we have this augmented matrix, means here our system of linear equation is 2 and this is 1. For this system of linear equation, augmented matrix is this one. Now we will apply row operation to change it in row echelon form or reduced row echelon form. So let's change to till row echelon form. Row echelon form is enough to tell you no solution, unique solution. No need to change. No need to change the augmented matrix in final. That is reduced row. No need to that much. Enough to row echelon form only. So let's do that. So our this is here -1. So change this with the 1. After multiplying, that is saying to be -1, multiply the -1 with R1. This will be 1, this is -1, this is -2, and this is -1.
May I interrupt, sir? I have one small question.
Yeah.
Sir, while reducing to row echelon form, is there any criteria from which row should we start? Or which column should we see?
Which row?
Or we could arbitrarily go from.
So which column, which row should be we need to choose, right?
Yes, sir. Or we could choose arbitrarily by it is just an observation. We have to observe.
No. Actually, there are some conditions. Suppose your matrix is here. I am changing here. Suppose this is 1, 0 here. There are some conditions. So suppose your matrix is augmented. Your matrix is this one. So reduced row echelon form says the 0 should be the next 0, because see, we need to make it 0 here, but here itself 0. So that means you should what you will do, you will change this row with this row and make it 2 above. That is, the first non-zero should be always right 2, left 2, right? Because you mean to say you need to change your matrix in upper triangular form.
Okay. Right, sir.
Okay. Suppose is here 0, so you need to interchange these 2 rows and now make it 1 here. How you will make it 1? Divide by 2. Okay, divide with 2. So our original thing is -1 here. So I need to make it 1 here. So that's why I multiply with -1. So we got this. Now see why this main thing is making 1 is, see, 1 when you want to make it 0, you just multiply with 2 and subtract. So making 1 makes easier to do all the operation easily. That's why we used to make it 1. Otherwise, without doing 1 also, you can conclude, but that will be more difficult to do the row operation. That's why.
Sir, can I ask something related to this?
Yes.
Sir, during reducing into row echelon form, can we interchange the row?
So yeah, actually we want this row echelon form, so we have to change as previously we are doing. Here is 0, then we have to interchange. The next step will be we have to interchange. Right? Row 1 will be interchanged with the row 2.
Okay. Will not go there will be no minus sign as we are doing with the determinant thing.
A minus sign?
Like during
no. So we are not working with the determinant here. Only we are changing in row echelon form.
Okay.
So don't.
So it doesn't make any difference, right?
Doesn't make any difference.
Hello, sir. Can I ask my doubt?
Yes.
So as you said that when right side is equal to all 0, then we do have only coefficient matrix, right? So in that case, like we do have a solution x and y is equal to 0 only, or is there any other possibilities for solution?
No. Can you repeat again? Sorry.
Like on the right side,
all are 0. Okay.
All are 0, right? So we do have only coefficient matrix. So what are our solution like for x1 and x2, x3?
So see, our system is now homogeneous in that case. Case, or have infinitely many solutions. So
and also it could be like 0, 0, 0.
So it can be 0 when it's depend our coefficient matrix is non-zero. Determinant of coefficient matrix is 0 or non-zero.
Okay. Or if determinant of coefficient matrix is 0, then it could
infinitely many solutions. It makes sure that the system has infinitely many solutions.
Okay. Thank you.
So let's make to the next step is this operation will be R2 minus 2 R1. So it will be 1 minus 1 minus 2. This is -1, and R2 minus R1 it makes 0 here, and this will be -2. It will be 3 here. This is -4 and minus, it will be 4 here, I think, and this is -2 -1. It will be 1. Please make correct if I am making numerically wrong. Okay. And this is, see, this is 0 here, so no need to do next operation. Just write the rest all.
Sir, in place of 4, I think it will come 2, right?
Yes.
R2 minus 2 plus 4, so it's 2.
Yeah.
Now, see.
Excuse me, sir.
Hmm.
Can I ask a question regarding this?
Yes.
Sir, in lecture, there are dependent and independent variables are there in Gaussian elimination.
So I will back to this. Here itself, I will discuss the independent and dependent.
Yeah, dependent variable and independent variable that.
From here itself, we will decide the independent and dependent and independent.
Okay, sir.
So it will. So now we need to make it. The next one is 1 here. This is called pivot element. So pivot element, we need to 1 here. So that means R3 divided by 3. So see, I want to hear a clever thing. If I will say, if you are observing it, if you see that these two rows are same.
Determinant is 0.
Sir, A2, 3 should be -6, I think.
A2 to 3, there will be -6.
2
minus plus, no, it will be 2, because multiply with 2, this will be -4, and subtract to -2, it will be plus.
Yes, sir. Sorry, sir.
So now if you see that these two are same, so if you want to divide with 3, or directly if you say that R3 minus R2, if you do that, it will be 1 minus 1 minus 2, and this is -1.
We are getting the determinant of coefficient
and
matrix
rest
0.
all will be 0. Rest all will be 0. Okay. Now next step, you can make it 1 and do the things. That means R3. Now you can do R2 by 3. So it will be 1 minus 1. That is means we want the row echelon form.
Sir, how did you take the third row as all zeros? Like, why did you convert it?
These two are same, right? Just subtracted here. I didn't did the R2 by 3. I seen that, okay, these two are the same, so I just subtracted. Now I am making it 1.
Is it necessary to do that, sir, or
see, it is totally up to you. It is totally up to you. If you want to make it 1, okay, make it 1 here, then multiply with 3 and subtract, or you can we are able to see these two are same, so let's subtract and then let's make it 1 now next.
Okay.
It's totally up to you. So this is 3, this is 1 here, this is 2 by 3, and this is 1 by 3. See, at the end, we want final thing is solution. Otherwise, see, if you suppose you are solving in the writing, like in the pen paper exam. In pen paper exam, you have to go with first make it 1. If teacher is asking, he want to see your operations, how you are doing, so that's the next step. You need to make it 1. Otherwise, if you are alone and you want to quickly find the solution, you can jump. That's I mean to say. Nothing. Okay.
So the final outcome should be only this much, right? Like, that's it.
So final thing is this is in row echelon form, right? Now because this is 1, this is 1 here, next all are 0. So this is in row echelon form. Now see, you have, this is the augmented matrix. After changing this matrix, this is the system. We have this system of linear equation. We got this augmented matrix.
Sir, but in the row echelon form, or even in the third row, we should have the leading element as 1, right?
No, in third row there is no leading.
It can be 0 also, all 0.
This all, yeah, see, we are making, see.
Sir, like the row echelon form, as per what I went through the lecture, it's like the leading element in each row should be 1. So
each row should be 1, but there are some row which contain, there is no non-zero row. Sorry, there is no non-zero number. There
Okay,
are
so
some
if
rows.
if it is if it's a non-zero row, then the leading element should be 1 in any
One.
case. That's it.
Yes,
Oh,
yes.
okay.
If all are 0, that should be below, always very below to this the non-zero row.
Okay, sir.
So now can
Sir,
you tell what?
sir, I have a question.
Sir, in
Yes.
this there will be no solution. That means.
So let me conclude here. So let me conclude here. No solution, infinitely many solution, and unique solution case. So
Sir, just one question. In this, the dependent variable will be x1 and x2?
so no, so still you have to see we will conclude dependent, independent after changing this matrix in
reduced row echelon form.
Okay.
So next
Yeah.
step, let's make it reduced row. We will remain it as it is. Let's change it in reduced row.
R1 plus R2.
R1 plus R2. So it will be 1 because this is this is our first pivot element. I made it 0, below and above there is no, so there is no mean. The next is this is our leading entry. This is 1 here. So below and above should be 0. That is the mean to be say reduced row echelon form. So that means we have to make it 0 here. So how we will make it after adding R1 with R2. So this is 0 here. If you add this, it will be minus 2 plus 2 by 3. It will be 6, 4 minus 4 by 3. And this is minus 1 plus 2, 1 by 3. It will be minus 2 by 3. Minus 2 by 3. And rest R will be as it is. So 2 by 3. And this is 1 by 3. 0, 0, 0, 0. So see, this matrix is in reduced row echelon form. Why? Because this is the leading one, below and above 0. This is the leading one, below and above 0. This entry is not leading to any row. So it can be 1 or not, it's not depend. And this is not leading, so no need to this is not meant to say making here 0. The only leading, whatever the leading term is, leading entry, that should above and below should be 0. That says reduced row echelon form. This is not leading, so that's why there is no mean to making 0, and also this will never be 0. How you will change it 0? If you change it in 0, this will become non-zero. So reduced row echelon form says the leading entry, leading call in the when you change in reduced row echelon form, the pivot element, whatever the pivot element in each row have, the below and above rows contain 0. That is that particular column contain only that non-zero entry, which is this one in this column. That is in reduced row echelon form. Okay, so this is in reduced row echelon form. This is the reduced row echelon form of this.
So what is this pivot element?
So pivot elements are this one. I mean saying to be pivot elements are in this form. You can say this is your pivot element, and you want pivot element to 1. So you are asking pivot element. What is pivot element?
Yes, sir.
Okay, so pivot element is, see, in this row, the pivot element is this one. The first non-zero number is called pivot element. Okay. In this row, this one is the pivot element. Suppose your number is here. Suppose this is 0 here, and this is 1. Suppose this is 2. So in third row,
we can also call it a leading coefficient.
Leading number or something is called. So in the third row, your pivot element is this one. You need to make it 1. The first non-zero number in that particular row.
Sir, I have a doubt. I think means leading entries are corresponding to columns only, no?
Leading entry
means only in means it can be defined in the columns only, right?
Leading entry. No. What leading entry?
Yeah, leading entry means like say if we have a column, then we should have a means there is a means leading entry can be means we can see the leading entry in a column, like first column, second column, third column.
Okay,
We
leading.
can see
Okay,
leading
okay,
entry.
okay, okay. If you are assuming, okay. So leading entry. Okay, what about this? Then leading entry for this column. This column.
Leading entry will be like if one is present, like say here, but one is not present, then leading, like say if leading
So
entry.
no, so there is no leading. So leading entry means into
Yeah.
with the row. Actually, the leading entry means to leading entry in the particular row.
So
And
actually, means in lecture, means it is. I have studied that if ith column is a leading entry, then
ith
exercise
column is a leading entry. So this is the leading entry for this column, this row.
column, not
So that
column.
is the mean. Ith
First
column
column.
have leading entry means let's say this is our column. So this is our leading entry, right? This is our leading entry.
Yes, I mean I am asking like how will I know? How will we know that what is the leading entry in
See,
a
a leading entry is anything, any element which is non-zero and the first in that particular row.
In first row, that is that is the
So
first
it's a non-zero element, basically.
first non-zero is called leading entry.
We are
So
talking about
column.
row echelon form. It is concerning about rows, not columns. Row echelon.
It says
And
there.
they use
That's
row
why
echelon.
Leading element in
leading
a
row
row.
and leading entry regarding to the row. That is, let's say this is 0 here. So leading entry for this row is this one. This is the leading entry.
Hello,
So,
sir. And it lies
it
in
can
third
be
column.
means it can be said in columns also, no? But in lecture it is.
So in this column, this is the leading entry. Because in this column, leading entry lies. Suppose you are this is the our case here. In this column, there is no leading entry, right? Because our leading entry is here for this row. There is no leading entry for this column.
Okay.
Hello, sir. Sir, Professor told in his video that every non-zero, the first element of every non-zero row should be one.
One should be one in row echelon form or in reduced.
Should be row in one echelon form. Suppose that, sir, here, if row 1 and column 2 increase 1, suppose
row 1 and
column 2, matlab 1 2 element is 1,
okay.
And
This one.
then this one,
okay,
1, and then 1 2 2 3 element is 1, and then the 1 element is 0. Then we can say that is it row echelon, row reduce echelon
Sir,
form?
can you just make that matrix whatever
Yeah,
saying?
yeah.
Actually, yeah.
Sir, exactly. He's saying about the leading element should, for the first row, should lie on the second column. Means one entry is 0, then 1.
0, and then 1.
0 1. Okay, this one.
Yeah, 0 0 1.
Okay.
Yeah.
And
0,
suppose
1.
this is 0 or this is 1. Okay.
Yeah.
And
Yes, sir.
next one is 1 or maybe let's say 0 0 1 kind of thing. Okay.
Sir, take 1 year also. I just wanted
here
to,
one also.
in the first place, in the first.
Okay, let's make it 0.
Second row first.
Okay, here 1. Okay.
Yeah.
Then it can be on row echelon form, I think.
No, it cannot be, because
actually this is not in reduced row echelon form or row echelon form, because this is 1 here. This is the first leading one in the first row. The next one should be 0. The next one should be 0 to be here 1 only.
It should be towards the right side of the first element.
So actually
then
you have
only
to
it is,
change it. This is not in row echelon form. You have to, after changing it, will be in row echelon form.
But sir, what happened when?
And for this, we have to interchange rows 2 and 1. Interchange the rows, it would be in row echelon form.
If you change this, it will be in row echelon form. Just interchanging the row. Okay.
But sir, suppose we take 2 1 increase 0 here.
2
row
1. Okay. 0.
1 increase
Okay.
0. Then sir.
So this is in row echelon form.
Okay.
Yes.
But this is not in reduced row echelon form.
Yes. because of that 1/3 entry.
If you want to make it reduced row echelon form, see, this is not in reduced row echelon form. The reason is this is leading entry, and below and above are should be 0, but here is not 0. So the next step, if we want to change it in reduced row echelon form, you have to subtract it. The next step is 0, 0, 0, 1, 0, 0, 0, 1. So this is in reduced row echelon form. This is in row echelon form. This is in row echelon form, but not reduced row echelon form. Okay. If you want reduced row echelon form, the leading.
Sir, I have a doubt.
So yeah, for that, okay, that's why I want to discuss this also. I have for that I have written some question here. Which one is reduced row and which is not in row echelon or
yes.
This is this collection of matrices, and I want to which one is reduced row and which one is sorry.
We should have done this first and then do the question.
Okay. I will back to because the written.
Sir, is the Gaussian elimination done? Like
No, it is not done. Actually, see, so the same thing is remain to with the independent and dependent variable. That's why I back to you. Back to that question. Okay, so let's finish this one. Then we will go to reduce row echelon form. Okay, is it?
Okay.
So our main question is from here we will try to deduce when it have no solution, unique solution, or infinitely many solutions. From here only. Okay, so this is in reduced row echelon form. I wrote for the independent dependent variable, which I will discuss later also. First we will discuss no solution, unique solution, and infinitely many solutions. So see, when you change the augmented matrix, we are discussing here for non-homogeneous. Please make sure that this whatever we will discuss here for no solution for non-homogeneous. For homogeneous, I will back again. So for non-homogeneous, you slowly doing the row operation, you got this is the row echelon form. Okay. Now the cases are here when we will say no solution, infinitely many solution, unique solution. Suppose we got this is the row echelon form. The case is here this one. Suppose we after changing the row echelon form, we got this one. In that case, what will happen? Okay. Before that, okay, that will be more easier. Let's say make it 0, and I want to make it this matrix. I want to back to our system of linear equation using this matrix. Please let me know what is the system of linear equation for this particular thing, for this matrix, because this is the right side, this is the coefficient matrix, this is our main system of linear equation. We applied row operation, we got this matrix which is in row echelon form. So I want to back with the system of linear equation what we have these entries. So what is that?
The first one will be x1
plus x3 is equal to 0.
x1 plus
y here
minus y minus 2z
equal to
minus
1.
And this is y.
Y plus 2 by 3z is 1 by 3.
Is equal to 1 by 3.
And
And
one is 0, 0.
X plus y plus z equal to 0.
So that's why there will be no solution.
No. So actually, this have infinitely.
Yes. Right.
Why? Because see, we have two equation only. So see, if you send this side to this y is equal to this second one, the second equation, it will be y is equal to 1 by 3 minus 2 by 3z. Okay. Now what will be the x here? X here will be minus 1. Send all this side. So this will be minus 1 plus 2z, and y take from here. This will be
minus 1 by 3
plus 2 by 3
plus 2 by 3z.
So what is happening here? Yeah, okay, we got a solution, but in terms of z. In terms of z. So what you can means z can assume
any value
r x y z in real number. So z can assume any real number. So assume z is equal to t any real number. Okay. Now x will be whatever according to t, and y will be according to 2, and z equal to whatever the function of whatever you will say. This, let's say this is function of t, or maybe function of t means 1/3 minus 2/3 t, and z equal to 2. And this is whatever when you solve with the t. Okay. So this have infinitely many solutions. So what you will conclude here? Okay, I will write here the case from here only. Next one is suppose our
you mean to say whatever value we put a value for that and get different values of x and y each time.
I mean to
and
say
it keeps on going. So that is why it is having infinite solutions.
Infinitely many solutions.
Sir, is this a generalized statement that if we have 3 variables and 2 equations, then the system of equations will have infinitely many solutions always?
So actually, if you have 3 equations,
sir, can you write this matrix once again and explain for when it is going to have a unique solution?
Yes. So actually, so see, this is the case when your number of variables is more than number of equation. In that case, you have infinitely many solutions.
Sir, always, sir, always.
Just 1 minute.
Can you repeat?
Sir, could you repeat that?
Yeah, just 1 minute. Let me clear for myself. Not always.
Yes, sir. It would not be always. We use row echelon form when the variables we have and the
actually
we have
I think not always, because I will tell you. Let me tell you why. Because first, let me finish with no solution and unique solution.
Yes,
then it will be then we will conclude with the number of equation and variables. Okay. So suppose our reduced row echelon form is here 1. Okay. Well, suppose we got this row echelon form, the same matrix I'm saying, we got here 1. Okay. So now back, let me tell you what is the equation now. Here it will be
x minus y.
The last one will be 1.
Write it once again.
Last one will be z is equal to 0.
This is minus 1. This is
y plus 2/3 z is equal to 1/3.
Z equals to.
And then z equals to 0.
Z equal to 0. So see, what is happening here now. So you will put here z equal to 0, you will get y equal to whatever, and x is equal to whatever, and z is equal to 0. So see, this gives unique solution, right? So okay, I will also write here.
Okay, sir. Okay, it gives a unique solution.
So let me write two separately. Then I will show you difference.
Sir, please write the matrix in the answer. It is so clear.
Let me write in different place. Then I will show you the differences. What's happening here? This is 1/3, and this is 0, 0, 1, and this is 0. The next one is suppose I got reduced row echelon form in this form here 1, and all are 0. Here 1. Suppose or any number 2, 3, or let's say 1, any number, assuming to be any real number. Okay, there is no matter. Let's say 2 here. I got reduced row echelon form. Okay, but see, I need to reduce row echelon form, so it should be 1. So it should be 1 because this is the leading entry, and leading entry should be 1. So suppose the row echelon form of the changing this matrix slowly, we got this one. Okay. So now tell me what is the equation now?
Instead of z is equal to 0, it will become z is equal to 1.
0 is equal 0x 0 plus 0 y plus 0 z is equal to 1. There is no solution.
There is no solution.
Y plus 2/3 z is equal to 1/3 and 0 equal to 1.
Yes.
This is ambiguous.
This is the absurd case.
Absurd case.
No solution.
So what are you getting? So let me write here. The main case here is 0. Okay, I will back to this one. This is 2/3, 1/3, and this is the next one is 1 here. We assuming. So I wrote that all three cases. This one, and this one. Okay, these three matrices. Are you able to see the differences? What's happening?
Yes, sir.
The coefficient matrix. This is our coefficient matrix in this side. The coefficient reduced form of the coefficient matrix is this one. Okay.
Unique solution.
So in such case, when this and this there is a, see, this is
rightmost column
matrix, rank of, there is a term called rank, which you will see in later weeks. But without saying to the rank, the word rank, I want to say, I will not give any different name. See, what I mean to say here, whatever you got the row echelon form, if all are like here is see, if you see this is 0, below to that the right side of this one, because of this one it's happening, this line is below to that is 0 all, and see the differences here, and see the differences here.
Sir, I want to ask one short question.
If this case is happening, if you solve, when you are solving, and suppose the case is here below all are 0, or this case is happening 0,
infinitely many,
0, and this is 0, so you will make your line here only. So the what is happening below that all are 0, so in this case also infinitely many solution. So this is
Sir, I want to ask one question, sir.
Just 1 minute.
Sir, in augmented matrix, while doing this row echelon form, we have to consider the elements of this augment, all the elements of augmented matrix, the elements below this after this vertical line.
Not consider, you got after changing this slowly when you are doing operation, you got this final thing. So I see, sir, what I am
row echelon. Sir, we have to consider row echelon form for only for this coefficient matrix or all the elements of augmented matrix?
All the elements of augmented matrix.
See, we are dealing with non-zero and we are dealing with augmented matrix. So always with augmented matrix. So see, I made a line here, okay, but you can see after changing this row echelon form, just back to our system of linear equation. Our system of linear equation will tell you no solution, infinitely many solution, or unique solution.
In other, I asked the question another way. For so which elements should we consider for the row echelon form? Okay, I know the operations would make the elements in augmented matrix. It will change all the elements, right? When we operate, all the elements will change. But when we would consider that the matrix is in row echelon form,
so
we will consider first this
I will back. When we consider that, I will back. See, you see why I am this. I jump to here because you have to properly know when we will say a matrix is called in row echelon form, reduced row echelon form. Okay, so you have to be know when we will say we are saturated, we are reached to the row echelon form. Using that, you will say, see, from here, that's why I wrote, you have to know when our matrix is now in row echelon form. The whatever the cases written for row echelon form, you have to follow in the sense, when you reach the as such case, means saying to be your matrix in this form, rest is 0, and in this form, or this form, kind of whatever. I will discuss here when our final matrix is called row echelon form or not. Otherwise, if you know, that's good. Otherwise, I will discuss here which one is row echelon form or no, or not.
Maybe, sir, it would be better if we identify that first, so that we'll know what we're doing in the augmented matrix, how we're doing the.
Okay.
Yes,
No
sir.
issue.
Yes,
It would just take a minute or so, I suppose.
Okay. But actually, I want to. I just we are very near to finish this, so that's why I let me continue. So what I mean to say, if you got the final thing row echelon form, change your matrix in system of linear equation. Your system of linear equation will tell no solution. As here, see, you told me that okay, infinitely many solution is not. You told me that after this matrix, after changing
inconsistent equation, inconsistent system of equation,
consistent means
a unique solution.
And a unique solution, no solution.
Sir, infinitely many solutions and no solutions both are inconsistent now.
Infinitely many solution is no. Consistent means there should be a solution. There should be a solution. Non-consistent means no solution.
Parallel lines.
Parallel lines.
And if there are infinitely many solutions or one solution, then it is consistent equation. So first and second is consistent, and third one is inconsistent.
No solution is so inconsistent. Okay. So see, so I hope you know that no, there is no need to worry with this one. The Gauss elimination tell you have no solution, infinitely many solution or unique solution. How? Just find the augmented matrix, do row operation, you got the row echelon form, and from the row echelon form you back to your system of linear equation. System of linear equation itself tell you that, oh, no solution, infinitely many solution or unique solution. Okay, so this is the first thing. Otherwise, from here you can you can itself see that have no solution or infinitely many solution. The cases here, if such case is happening, the right side and the coefficient all are zero. In such case, infinitely many solution. For this case, the coefficient matrix contains zero, but right side is non-zero. In such case, no solution. Okay, the third one is, okay, coefficient
Sir,
matrix.
can you
The
say
last
it
one
again?
is, yeah, just 1 minute. Let me finish.
Last one is one.
One coefficient matrix contains like this, but okay, this is zero. This is
unique solution.
Unique solution. Let's say this is not zero. Maybe some non-zero number also. It can be 2, 3. Okay, but
it
still
will be.
it will tell the z is equal to O2. According to that, you can tell.
Yes, we can put z value in the second equation, and then after put in the first equation the value of y and z both.
So got my idea what I'm saying?
Yes, sir.
Okay, so someone had asked, someone have doubt here. Okay, can you continue? You can continue.
Hello, sir.
Huh.
Sir, you have taken 0, 0, 0, 1. Why not we take 0, 0, 0, 2?
So actually, why we are not taking 0, 0, 2? Because we want, if you took 2 here, this is not in our row
echelon form, not a row.
But sir, we have seen some type of things in like solve with us 2.2 question number 12. Answer, I think answer is saying 0, 0, 2 also.
0, 0, 2 is also, see, okay, no issue, but
reduced row echelon form.
There should be no word row echelon form. Means saying to be, he will not use in that question. The word is not used row echelon form. The word saying to be no solution case. See,
sir, can I ask one more thing? So can I ask one doubt? So to conclude this test, we have to reduce the system to row echelon form or
reduce row echelon form.
Reduce row echelon.
And then conclude this test.
No. I till here, this is our not case applied here. Oh, so this is, I told you the cases here. Not this is our in row echelon form. I'm saying the whatever.
Not reduced row echelon form. Just row echelon.
Only just row echelon form is able to decide no solution infinitely.
Okay,
because see, this is not in reduced row. This is okay. Here the case here. Let me make it one here. Okay, don't be confused. I am just told you cases here.
Okay.
Cases I told you what when these things are happening.
Sir, I think many people like me are confused with the row and reduced row echelon.
Echelon form and row, reduced row echelon form. What is the difference?
I will back. So till here.
And their application. Yes, a system of linear equation with augmented matrix is clear. How to judge?
So what I mean to say, now what you will do, change this 1 C with 1 D1, and if you do the operation and you got such cases here, you can directly tell, okay, no solution, infinite.
No, unique solution or infinite medicine.
Now let's back to when we will say reduce row and row echelon form. Okay, so suppose you have a matrix here and you did operations and you got like this matrices.
So we do operation with a particular m, na sir, that the last element is 0.
Last element will be 0, means to mean to say
it is 3 by 3 matrix, then the A33 should be 0.
You means to say you need to do operation like that,
such that the last element is 0.
Last element is need not be 0, means trying to be this form, in this form, like it can be 0 1 1 0 0 1 or 0 0 0 this form, or
upper triangular matrix or lower triangular matrix will also do
0 0 1 in this form, or it will be 0 0 1 0 0 0 0 0 0 in this form. These all are in row echelon form. The reason is this is the leading entry, our leading entry is 1. In this leading entry means, let me tell you. Okay, I took the first row. Okay, this is 0, this is 1. Okay, so this is 1, this is my leading entry. Okay, this is 1, fine. This is 2, make it 1. Now
by doing row operation.
By doing row operation. Okay, by doing row operation, I mean to say, yeah. So next one is go to the next row. Okay, this is 0. Okay, no issue. Suppose this is non-zero. This is 2 here or something number.
We have to reduce it to 1.
Make it 1 and no, not make
somehow.
it 0, because this is our 1 here. So below that we need 0. So make it 0 here, doing the row operation.
Okay.
So make it 0. The next one is come to here. Okay, all are 0, fine. Suppose non-zero, suppose this is 3 here. Okay, suppose here 3 here. Suppose 3 here, this is 0, this is 1 here. Okay, suppose this is case happening. So see, no. Okay, this case I will discuss later. Suppose this is happening, 0, 1. Okay, 1 here, and this case is happening. So see, this is our leading entry. Okay, no, sorry. For third row, this is our leading entry, but here is also leading entry. So what is here? 1 here. So rest all below that 0. All non-zero leading entry row echelon form says, while changing, what you will do, you will make it 0 here. Okay. And next one is in this row, this is 1 here. So this should be 0. Means always go to the right side. Non-zero means, are you getting? No, what I meant to say?
Yes, sir. Sir, actually, the last point you said, I got confused. Till now, I was clear. What did you say that since there was 1 in the second row, I have to make it 0. Had there not been 1, it would not have made any difference.
So here.
Yes, sir. Yes, sir. In the second row, you said now that the first entry of the second row is 1. That's why we need to make the last entry of the third row 0.
Because here now our leading entry in second row is here. So that means below to that 0. Here is 0. Okay, but below to that we need to 0.
We need to have 0
here. So doing the row operation, make it 0. So this is in the row echelon form.
So what about the second element of the third entry? Can it be 1 or 2 or
here?
Anything?
No. Here will be 0 because this is our leading entry for the first row, and below that we want to 0. Here is the leading entry for the first row. Below that 0. This is
all of them should be 0 below. After leading entry, all of the element below that in that column should be 0.
0. Make it 0 as here the case. Okay. Here should also be 0.
The element 2, 1 is 1 or what? Element 2, 1.
0. How could it be 1? It is
because
0.
You put 0 according to your.
Okay. Oh yes. Sorry.
Okay. Suppose the case here is 3 here. Here, suppose the case is here 3. So what you will do, doing the operation, you will interchange. This is 3 here, this is 0, and this is 0, and now you are interchanged here. This with this one. So this is 0, 1, and 1, and this is 0, 0, 1. Okay. So while doing the operation, you have to make it 1 here. So now make it 1 here, 1, 0, 0, and this is 0, 0, 1, 0, 0, 1 here. So this is leading entry, below that 0. Okay, this is leading entry. Oh, this is 1 here. This is 1. In this row, leading entry is here, but it contains more 0 with respect to this one. So again, you have to interchange this one and this one. That means interchange here. 0. So this will be 0, 1, 1, and this is 0, 0, 1.
So now it is in row echelon form, because every entry below the leading entry is 0.
0. For this row, this is leading entry. This is 0. The non-zero is right side of that. This is leading entry. Below there is no row. So okay, fine. So this is
interchanging 2 rows introduces a minus sign, sir, or no change.
Okay, in minus sign it will effect on determinant, but we are just changing the matrix. Okay.
Okay. So there is no effect on matrix if we do row operation like this.
No. So actually, we are trying to form the
linear equations.
So we have to turn it
to form the row echelon form of the matrix. We are not dealing here with the determinant.
So we have to turn it into a upper triangular matrix with diagonals 1.
Diagonals 1. It may not be 1 also. It may not be, because suppose the cases is here happening as here. It may not be 1.
Answer the linear equation we write after transforming it into row echelon form, not before that. To check the consistency of linear equations, we check for the consistency after converting the augmented matrix into row echelon form only.
Now,
then we write
now I have these matrices. You people will tell in your chat box. I will see that how many matrices are. You will write the matrix A, B, C in your chat. I will see how many of you are saying to, okay, this one is row echelon form, or this one. Which one?
We have to write which ones are in row echelon form, right?
Chat, in chat, please write. I will see.
Sir, only row echelon or did you?
Only row echelon.
Sir, privately to you or to everyone?
Everyone. Privately, okay. For me only. I will see.
Sir, what's your name in this?
Subham Piyori.
Okay, sir.
So your answer will be like, okay, A is row echelon form, type A. If B is row echelon form, type B. If B is not, so leave it B. Who is the row echelon form? But just let me know which one is row echelon form. Post okay, like that, like A B C D or B C D or E F G, whatever. Please, everyone, do that. That would be more better. Then I will know how many of you know. Because in this set, I have included all. What are the possible row echelon form? Almost all. You will see that while discussing. Yeah.
I think 7, sir. 7.
Yes, and total
Sir,
7.
Sir, are we supposed to do row transformations as well, sir?
No. Only just from no need to do operation. Only okay. This matrix is in row echelon form or not. That's all.
Okay. So we have to only check if the elements below the leading entry is 0 or not. That's all.
According to that. When many of you know good are assuming to be be D in the row echelon form, that is a good thing, because actually D is in row echelon form.
Could you repeat that? D is in row echelon form or not?
Yeah, D is in row echelon form.
But there is no leading entry there. Sir.
Yes, so not one is a leading entry.
There is no one, so actually this is not contradicting the definition of the form of row echelon form. That's why
there should not be any entry below the leading entry more than 0. So all of them are 0.
First entry of any
Sir, can you just scroll up to see the definition of that once?
So yeah, that's yeah. So I think let's discuss this now. Okay. Thank you. Thanks for answering. Many of you have answered. Okay. Okay. So a matrix is in row echelon form if. What is that? The first condition says the key points are a matrix in reduced row. So this time we don't want this. We want this one only, a matrix in row echelon form. The first non-zero element, the leading entry, is in a row is 1.
Is 1.
So it could be this row, whatever the row you are, the first non-zero element, non-zero entry should be 1. It cannot be 2, 3. So make sure that in any row, the first non-zero, suppose this row is 0 totally, so leave it. But this row is non-zero. So in that case, the first entry should be 1. It will be here, or it will be here, or it will be here. So okay, this is the case. The first this one says, okay. The next one is the column containing the leading one of a row is to the right of the column containing the leading one of the row above of it. What it means that, okay, the column containing the leading one. Suppose our case is here.
All element below the leading entry in the column should be 0.
Okay. No, so let me finish that. Suppose this column containing leading one. What it means, the leading one means, suppose this is 1 here. 1. So this and rest all are 0. Here is above, below is 0. So this is called the leading one for this column. Okay. Okay. Above and below, not 0 means to say, okay, I will say in this form, using this matrix we will conclude. Okay. So what is said, column containing the leading one of a row. Suppose this row is contain leading one here. Okay. So this leading one is lying in this column. So below that, what is mean, right? The leading one of a row is to the right of the column containing leading one of its above. So suppose here is leading one for this one. So the next leading one be here, not here. That mean to say, if suppose leading one is here only, the next leading one be here, not here, not here. That mean to say, the next second, the second. And the third one says any non-zero rows are always above the all zero. The third one says all. Let me mute all of you. Okay. It means to say 0 rows. There is no non-zero. Means all our entries are 0. That should be always below. Always the beneath in the sense you can say. That's mean the third one says. Okay. Now let's back to our here this question.
What was the third condition?
The third one says the 0. The 0 means a row containing all entries are 0. It will be always below to the non-zero, to a non-zero. But even if suppose a row is contains 0, only 0 is entries, that should be below always. Okay. Because below always means you can change it to, you can interchange the rows. to make it 0, to make it below, that mean to say. Okay, so like let's say this matrix, is this in row echelon form?
Which one, sir?
This is the first one.
No, sir.
No, sir.
The reason is, for this row, the leading entry is here. Okay. The next, for the next row, the leading entry is here. Now
left
here,
it should be in the third row only.
So it's
third column.
Not a row echelon.
Third column.
So actually, this is in no echelon form because it should be not here. It should be somewhere here or here, not here. That mean to say,
yes,
it can be lie here. It can be right side of that, not here.
And
so
also,
this is the leading entry for here, but it is not lying in the right side of the above one. Okay. The next is again here is, this is the leading entry for the third row, but again it is not lying in the right side of that. It is lying the below of that. So this is not in row echelon form. Okay. B. Now back to B. Is this in row?
This is also not.
No, because the leading entry should be 1. It is minus 1.
Because the first leading entry of row 1 is minus
not 1. Yeah. So for the first row, the leading entry is here, but this is not 1. So directly, this is not an row. The second row leading entry is here, but okay, this is 1, but the first one is not. So you can contradict that. Oh, this is not in row echelon form. The next is about the
This is row echelon.
Is row echelon.
So let's check this. This is the leading entry for the first row. This is okay, and okay, fine. The second row leading entry is here. Okay, it is lying the right side of.
Yes.
Right side of it. Okay, good. The next, the third row leading entry is, there is no leading entry. So okay, so this is fine. This is in row echelon form. Follows the condition. The third one, D. So D is why it's lying row echelon form, because there is no non-zero rows. All are zeros. So it is not violating the case for the row echelon form. Any case. The condition says when is non-zero row, then we will consider. But there is no non-zero row. So it is not violating the condition of row echelon form. That's why it is in row echelon form.
So in the C case, if we have 2, 1, 0, then it is not.
2, 1.
The first row, if it is 2, 1, 0.
2, 1, 0. Okay.
Then it is not.
So this is not in row echelon. Now let's come to here. The case C, this is not always C. This is not in triangular form. Here is 0. So it cannot be, but the mean to say always the non-zero or leading entry should always lie to the right side. Suppose
it is not necessary for the
it
matrix
cannot
to be
be
upper
in the
triangular or lower
upper triangular. It can be, see, some entries are, you can say this is in upper triangular. You can say, okay, this is in upper triangular, but yeah, some entries in the upper triangular can be 0 also. That mean to say.
So actually, the diagonal elements are all 0. Then we can't, guarantee that it is in row echelon form.
Diagonal entries is 0, but
in an octave.
But suppose this is 1 here, then see, this is all diagonal 0. Suppose this
no, sir. I am asking about the upper triangular matrix.
Okay, then still it is. Yes, then it is.
Sir.
Sir, one more doubt.
Leading entry should also be 1. Not
in A, if we take in A,
so it should be 1 here. We make it 1 here, then it will be.
Yes, sir. Exactly.
Okay.
Sir, matrix A now, if we interchange R2 to R1 and R1 to R2, can it be this one? Sir?
R1 to R2 means 2
sir,
cross. R1 to R2 means what? Sorry, R1 to R2. Sorry, this R1 to R2. Okay.
Yeah, sir. R1 to R2 and R2 to R1. Can I do?
After doing you can, but while looking you need to confirm. Just here is the question is this matrix in row echelon form or not? That's the question.
Okay.
After doing operation you can do. After doing operation you can change to this in row echelon form. But is this matrix in row echelon form or not? That's the question. So again for the third E question, is this in row echelon form?
No, sir.
No.
The case is here.
Because the leading entry of the second row is
not
just
right
below
side.
the, yes, sir.
Just
Is
below
on the same column. Yes.
So the first row is leading entry is here. Okay. For the second row, leading entry is here, but the case for row echelon form, it should be here, then we can say, but it is not the case. So again, it violating the form. Okay, for this case,
yes,
leading entry is here. This for the first row. For the second row, leading entry is here. For the third row, leading entry is here. Okay, so always align to a right. So this is in row echelon. And all are one also. Suppose someone of is
but
2.
sir, there is a one above.
One above?
In F.
Here. So no matter. This is not leading. This is not
in reduced row echelon form.
This case will come in reduced row. Again, I will ask the next question is it. Suppose the case here it is 2. Then it will not, because okay, always non-zero is lying right side, but the leading was is not 1. So we can say that this is no for if here is 2, but here is our 1, so this is in row echelon form. The next one is this in row echelon form?
Yes.
Yes, sir. Yes.
The case here is okay, leading one. Okay, this is the leading one. For the second row, here is the leading one. Okay, sign lying to the right side of it. So see, all are 0 always. The rest all this side will be 0. Then we can suppose someone is here 1, then it will never. Okay. So this is in row echelon form. For this case, again the same thing is happening.
Yes.
This is also.
For this one, this is not because of this one. Because okay, lady following the right side, but not following the one case. It should be 1. Okay. Now the case is here. Okay, leading one is here.
Yes.
Identity matrix is
Yes, sir.
Yes.
this is, and this one.
This is
Yes,
also.
sir. This is
also.
This is also because this is the following the case 1 and leading one right of that. So this
so in G, if the 3-1 element is 2, then also it's then what will
3-1.
G in G matrix, if 3-1 element, the third row and first element.
3-1. Okay, here 3-1.
If it's 2.
So then it is not. It is not. The reason is the leading entry is here. The leading entry is here. This is not 1, and the second thing is it should be always the above to right. Above the whatever the leading for above the row, it should be right to right, but here is not the case. So violating to both cases, not 1, and it is not lying to the right side. It is following the third case. See that all are 0. Okay, so this is actually in row echelon form. So see that it is following the case all 0 rows, means a row containing 0, all entries are 0. It is see that it is always below to the non-zero row. So yeah, actually the case for this is it. So this is in row echelon form. The cases I hope you got.
Sir, can I ask what about I? The third row is -1. The leading entry becomes -1. It is not 1. So will it be?
So I cross it here. This is not in row because our leading one is not 1. Oh, yeah, this is not in row echelon form. So let me erase. Okay. K is identity matrix. It is follows the all property of follows the form of. Yeah, it is 1. It is right side of 1 and right side to this one is 1 also. The third one is okay. All our cases fine. So this is in row echelon. Yeah, so this is in row echelon form.
And if the first row is all 0, then it will not be row echelon form.
So suppose this is the first row is all are 0. Okay. So this is not in row echelon form because this contain the violating the third case. It should be
all elements
should be 0, means
below the
are always above to with the all zeros. So
yes,
this is, if suppose this is 0 here, so it should be here, not the above of. Okay. So this is not the row echelon form. So let me erase now. From here you have to choose reduced row echelon form. Before that, let me clear what is the criteria when a matrix called in reduced row echelon form. So let's read out that, and then I will leave to you, because here also I approximately contain all row echelon form, reduced row echelon form. Okay, so the conditions for
I have still confusion in augmented matrix, sir.
Augmented matrix is why?
Suppose if I think, sir, this should only row echelon form of coefficient matrix.
So still, see, forget about that line, vertical, forget about that line. That is your matrix. Say that is your matrix. Now you need to be in row echelon form. Oh, will it be, it is now fine. Forget about that vertical line. Now your matrix is in row echelon form.
Sir, could you please question number 12 solve with us? 2.2.
I will back. I will back. Okay. I will back. Let's
Thank
finish.
you, sir.
So let's take this. This is the case for reduced row echelon form. It says the first non-zero, again the first case here, the same thing is, it says same thing. The first row leading is 1 here. Okay, is 1 here, the same as here. The second is all subsequent non-zero rows must also have their leading entry as 1, and they should appear to the right of the leading entry in previous row. This is the same case here. Same case, same thing is here. All subsequent non-zero rows. Okay, now subsequent means this is there, subsequent, this is the row. So subsequent row is this one for this row. All the subsequent row must have leading to be the right side of the same. This is the same. These two are saying to be the same thing. Means always lie to the right of the leading one. The third one, the leading entry in each row must be only non-zero number in column. This is the different thing now. The last one is also the same thing. Here is the only difference is the leading entry in each row. Suppose this is the leading entry. Suppose for this row, this is the leading entry. Not here. This is the leading entry. So leading entry in each row must be the only non-zero. What it means that it must be the only non-zero in that column. That column. Suppose your leading entry is for the second row. Suppose the case is 1, or let's say this is 0 here. Okay. Suppose this is 1 here. The second one is here. For the second row is your leading entry is here. Okay. Leading entry is here. So in that case,
third column.
In that column, third column, the above and below, in this column, the leading entry, what is it? The only non-zero number is this one, that leading. Rest all is 0. This is the case for
above and below
0.
It will not 0. Okay.
Above and below should be 0. So this is the all three conditions are the same. Only this makes a difference. That means okay, forms are the same. Means to say you have to find the row echelon form. Now do the operation to form reduced row echelon form. After finding the row echelon form, do the operation to find the reduced row echelon form. So make it the leading one above and below. Above and below rows should be leading one 0 entries. Sorry, not row, entries. So let's back to here. So choose from here again. Same. Do the message privately to me, and I will see how many of you are choosing saying to be there in how many of matrices are in reduced row echelon form.
Sir,
many of you are.
Sir, I have a small doubt regarding this one.
Okay.
Can you go to activity 2.4?
Okay, let's do this. Then we can. Let's do this. Okay.
Sir, what about that dependent and independent variable in this?
So let's finish this reduced rows. Then we will back to the dependent and dependent, because dependent and independence totally depend on reduced row. Okay. So next I will go to this. Okay.
Hello. Sir, in the Gaussian elimination question, the answer was just that it has infinite solutions because the last row is all zeros.
No. Last rows
Are we
all
done?
are. We done, right? We totally.
So it was just infinite solutions. That was the answer, right?
For the first option, the system has infinitely many solutions.
For the first option, yeah, we did only the first option, so it has infinitely many solutions. That was the answer, right?
That is the answer.
So we don't have to go any further. We don't have to reduce the rows any further. Because we got all zeros in the final row.
Otherwise, if you are confusion with that, so change that matrix in the system of linear equation, then conclude. That's I mean to say. If you are confusion with the form, change your matrix. Change your matrix with the system of linear equation. At least find your system of linear equation using that matrix, and then conclude.
Okay, sir. Thank you.
Okay, so let's do then. Yeah, let's see.
Sir, I have a doubt in activity question 2.1, number 4.
Okay, yeah, okay.
Just for review.
So please, please raise your hand. Please, everyone.
I already raised my.
So please keep raising hand. I will back after finishing this one. Because after finishing this one, I will be conclude independent and dependent, then started activity and doubt. So let's discuss this one. Okay. Which is C D H J K I. Okay, so okay. So let's see that. If you are solving, if you wrote your answers, that's good. And thanks for answering.
Sir, will we be extending this session beyond 4 p.m.?
Maybe because yeah, after this is independent is remain, then your doubts are remain. So it may go because only 9 minutes is remain. So it may go for the 2 hours. Okay, so let's discuss this A. So let me tell you that every reduced row echelon form is row echelon.
Yes.
Because the reduced row echelon form is after see all properties, if you match with this, all R3, the extra is here. So what it means, the reduced row echelon form is always row echelon form. Row echelon form may not be reduced row, but reduced row echelon form is row echelon form. What I mean to say in the implication form, I will say this means if your matrix is this will surely happen, but this is the not case. Means here is your row echelon form, here is reduced row. So row echelon form cannot be reduced row, but reduced row surely will be row echelon form. In the get the logic format, I will say. Okay, so as previously again, this is not in row echelon form. Otherwise, let's discuss with these things with the condition. This is the leading entry here 1. Okay, the next row is leading entry is 1 here, but it should be somewhere this side, right side. So violating that the first condition itself. Sorry, this one, second condition. Okay, second one is again, the leading entry is not 1, so this will not. For this case, let's see this case. Okay, so for the third one, this is the leading entry. Okay, and for the second row, this is the leading entry, and 0 is lying to the always below. So following the row echelon form. And okay, now back to the next condition, reduce row echelon form. So this is the leading entry, and this is the particular column. So in that, this is the only non-zero number which is leading. Okay, fine. This is not our leading entry. This is our not leading entry. Okay, is it clear? This is our not leading entry. Okay, for this row, this is our leading entry. This is our corresponding column. The non-zero is only the leading entry, rest all are zero. So this is in reduced row echelon. And the cases here for the D, if you see that there is no non-zero, and if there is one, see that in each all are zero. So it is following the reduced row echelon form case. It is not violating any case for reduced row. So this is in reduced row echelon form. Let's back to here. The third E, this is leading entry, and for this row, this is leading entry, but below
Sir, D doesn't have one. So why is it?
D doesn't have one, but it is not violating the case. Okay, no, there is no one, there is nothing. So
the first non-entry in the first row should be one, the first condition.
So for the first condition, the non-zero element is one. If non-zero element, if your matrix is non-zero, let me say, if your row is non-zero, then it is happening.
Okay.
If your row
is non-zero, if the row is having all zeros, then it is by default row echelon.
Okay.
If there is no non-zero row, then we have to check the conditions.
Then we have to check the conditions.
Okay.
Let's check this here. This is leading entry. Okay, fine. For the second row, this is leading entry. Fine.
But one is there.
But okay, we didn't check here for the column. For the leading one, rest all are zero. Okay. This is leading entry here. Let's make it column here. Okay. Okay, this is not here.
One above it.
It should be here 0, then it will be. So it is violating the reduced row echelon form case. So this is not in reduced row echelon form, but it is in row echelon form. It is in row echelon form, but not in reduced row echelon form. Same case here, and the next one is here. This is one. Okay, make the column. Okay, this is leading entry. The cases is like this is leading entry. Okay, make the column below and above it 0. Okay, fine. Okay, the next one is this is leading entry. Okay, make the column below and above should be 0, not 0. So this is not in reduced row echelon form. Similarly here, if you see that all are following. So okay, this is in reduced row echelon form. Okay, now here is again this is leading entry but not 1, so it cannot be for our case here. Okay, this is the case. Leading entry is here. Okay, and this is 0. There is no leading entry, so no need to worry. This is here the leading term. Okay, make it column below and above all are 0. Fine. This is the leading entry, and 1 also. Make it column below and above is 0. So this is in reduced row echelon form. The same case for identity matrix will happen if you make column also. Here is, if you see that. Okay, so this is in reduced row echelon form for this one. Okay, leading entry is here. Make the column below and above 0. Okay, fine. This is leading entry below and above 1. Okay, fine. This is our not leading entry, so it can be non-zero, no matter, because this is not leading entry. If you form that, this is not our leading entry, this is our not leading entry, so below and above no need to worry. It is clear to all of you, right? For this
yes, sir.
So
yes, sir.
Make your column. If your entry is leading, below and above should be 0. For this case, these are not leading entry. That's why no need to worry. Okay.
D is also in reduced form.
So this is in reduced row echelon form.
D.
D. Where is D is in reduced row echelon form. The case is here if these conditions are follow when it is non-zero entry is happening. Okay. Otherwise, if you think 0 as an exceptional case, you can assume. But the cases given for when the non-zero element is happening.
If all elements are 0, then it is already in row echelon form.
Automatically lie in the reduced
row echelon. We have, if there are no non-zero elements, then we check for the conditions.
So now let's back to the independent and dependent variable. So I'm writing here. Here itself we will discuss. Which one is, let me note it down, which one is in reduced row echelon form, because independent variable is done with the first your matrix should be in reduced row echelon form. So our reduced row echelon form is this one, and this one.
K also and L also.
This one. Okay. So suppose you have a system of linear equation. Okay. You have a system of linear equation, and for the homogeneous case, non-homogeneous case.
So first, let's do it for homogeneous.
Let's do for homogeneous, then we will discuss for non-homogeneous. For the non-homogeneous also it will work. Yeah, it will, for the non-homogeneous it will also work. So that's why I was thinking. So okay, suppose you have a system of linear equation, and okay, for non-homogeneous case we will make it separate. Suppose your system of linear equation is homogeneous system of
Sir, what is the meaning of homogeneous system of linear equation?
Homogeneous means
right hand side is all zero.
All are zero.
All are zero.
In such case, your system is homogeneous.
And if non-zero, then non-homogeneous.
Non-homogeneous. Okay. So your coefficient matrix is in reduced row echelon form. So sorry. So you have a system of linear equation, and suppose your coefficient matrix is this one. After doing the row operation, you got these reduced row echelon form. Any one of them. Any one of these is in reduced row echelon form. It will not apply in row echelon form. It will apply only reduced row echelon form. So what is the process? So suppose this is our reduced row echelon form. Just write above x1, x2, x3, because this is the matrix you can write, because if you multiply, mean to say x1, x2, x3, you can back to the system of linear equation. So you can directly write to above. So who have, see, you can make it column if you want. So who have leading entry? Those are dependent variable. Which,
yes, x1 and x3 here.
Which one have leading entry? Like for x3, leading entry. For x2, there is no leading entry. Okay, these are not, 2 is not leading entry. For 2 is, here is the leading entry. So who have leading entry, that is dependent. Who have not leading, that is independent. So for our case, x2 is independent, x3 and x1 is dependent.
So sorry to interrupt. This is for homogeneous case we are discussing.
For homogeneous case. Actually, it will apply to the non-homogeneous also. Okay. But we will make it separately also here. Okay. We will discuss separately. It will actually work for non-homogeneous also.
Okay.
So suppose your reduced row echelon form, you got zero matrix. Okay, zero matrix you got. So how many, then can you tell me how many variables are independent, or which are the independent?
All are independent.
All are independent.
All are independent. All are independent. So actually your system will be 0, 0, x plus 0, 1. So all are, actually you can give any value to x1, x2. Independence means what? You can give any value to that variable. That's the mean. Let me mute to all of you first. Independent means you can give any value to that independent variable. Dependent means it's assuming one, like x1 assuming one value, x3 will assume one, x3 is equal to 1, x1 is equal to 1. Not 1, sorry, it will, after the solving, it will assume the one. Yeah, but you can give to x2 independent. You can think x2 as independent. So that's the mean independent. Suppose your matrix reduced row echelon form is this one. Just write above
Sir, could you repeat that? X1 and X3 are dependent and X2 is independent.
So suppose you are
yes, sir. Can you please repeat it one more time, sir, please?
Okay. Okay. So yeah, actually, maybe in that independence means when you are solving a system of linear equation, you can give that variable as a t, and it's assumed like here our case here, as here leading is 1, so x3 is dependent, x1 is dependent. For the x2 case, it is not, there is no leading entry, so x2 is independent. What it means, say, what it means independent means when you solve the, when you form again back to the system of linear equation, you can give x2 as a t means any real number, and rest all are x1 or x3 work as a dependent. It can be dependent on t, or it can be x1 is equal to 1, x3 is equal to 1, and x2 is equal to t. It can be like that, or it can be the function of t, means it can be means writing to be x1 plus x2 is equal to, let's say, 0, means x1 is equal to minus x2 means minus t. So it can be in the form of t or a particular value. Getting? No?
Yes, sir.
That's the mean to independent means.
All elements, all variables, or just one variable? I mean, you are talking about particularly x1 or x1, x2, x3, all of them.
The x2 is for our case, x2 is independent, so x2 work as it can assume any real number. X1 and X1.
So how did we know that x2 is independent? What was the criteria?
From here we are saying, right? X2 is independent. From here we are saying.
Because it is 2, it is not 1.
X2 in the x2 column, for the x2 column there is
no leading entry.
So that means it is free, and it is the independent. X2 work as an independent variable.
So to know the which one is independent variable, we'll have to check that which column, which row is not having having a leading entry.
Leading entry.
If there is not a leading, if there is non-leading entry in a row, then it will be independent variable.
Independent. As let's see, as here, this is in this is not in reduced row. This is not in reduced. This one is in reduced row. So let's make it 1 here, x1. So where it?
So means
C is in reduced row, na sir?
C is in reduced row.
So means if a system of linear equation have at least one independent variable, then it will have infinitely many solutions.
Okay. That's the mean. So let's
repeat what you just said.
And we have to check in the reduced row echelon form only, na?
Yes, it will. Yes, we will only have to check for reduced row echelon form. Yeah.
Sir, please can you repeat what you just said?
So I mean to say, but one thing is the system is have solutions. The case is here, I said independent, but suppose that system has solution and it contain a independent variable. Then in that case, that system has infinitely many solutions.
Okay, it will. Yes.
Okay. So
and sir, if all the if all the columns are dependent, then it will have unique solution.
If all columns are dependent, then it is like for the identity case we will see.
Yes.
Identity matrix.
Yes,
sir, can you look at activity question now?
But just one
minute. It is similar example.
Okay. So let me finish.
If non-leading edge is 1, then
non-leading is,
if the non-leading element is 1, then what would be the case?
Non-leading, suppose this is one here, still it will be as independent. This is not leading and this is 1, so it still it will be, because leading means it is not work as means as a definition is given, meant to say, if that change the matrix in reduced row echelon form, and like that, if you write, it's better to, if you are writing here, it's better to write here itself. It will carry the same, and decide and which one will be independent or dependent.
Sir, when it will have no solution in the reduced row echelon form?
No solution, then what we can say? Okay, the for matrix and all, if someone is asking independent, dependent, okay, you can say independent. But the system, regarding the system he is asking, so there is no solution also. There is no mean to ask independent, independent.
So, sir, can you just give an example?
So first we'll have to check if there is a solution
which,
or not.
Yes.
Then we will have
system
to
which
check.
is in
the question can be different also. Means somebody's are like, the question is, you have, suppose you have a system of linear equation, the coefficient matrix is this one, and he just want to ask you which variable is how many variables are independent. That's all question. He's not asking the solution. In that case, just only need to change that coefficient matrix in reduced row, so reduced row echelon form, and decide that. That's all. There is nothing the case here. In that question, who is made that question, in his mind that he assumed that system is
yes, sir. I mean to say that suppose the system is in suppose the system of linear equation is in reduced row echelon form, and can this system have I mean no solution? Is there any case?
It can have no solution. For the non-homogeneous can happen. For the homogeneous, it will never.
Is it absolutely? For non-homogeneous, can you just give an example?
It may or may not. I have to check. While discussing, we will reach. While discussing for the non-homogeneous case, when we will reach, we will discuss.
Sir, just one more just doubt clarification. You said if all the variables are independent, then
sir,
there is
sir,
unique
sir, I think I have
solution.
got an example. Suppose you take that D matrix. Then it will have, and it is a non-homogeneous.
No. So yeah, actually, somebody has asked. The question is, it's depend on question. So he said that, yeah,
okay,
like yes. That the coefficient matrix is this one. So he assume in that question, he is the question maker is assume that, okay, system is homogeneous equation. That means right side at 0. Only need to work with the coefficient. That's all. So question will be like that. The coefficient matrix of the, or coefficient reduced row echelon form of the coefficient matrix is this, then how many variables are independent? That's all. This is the question. So in that case, you will just tell how many independent. The question maker knows that, okay, system is homogeneous or not. It's depend on him. The question is simply asked, the coefficient matrix of a system, the reduced row echelon form of the coefficient matrix of a system of linear equation is this, then how many variables are independent? That's all. This is the question. In that case, you will just tell, okay, this many variables. As in activity, you can see like that questions are.
Sir, could you just explain again the dependent and independent variables and unique solution? That if all three are independent, then there is a unique solution.
No, all three are independent.
All three are dependent. Then it will have unique solution.
All three are dependent, then they have unique solution.
Yes.
There are two cases.
Like in identity matrix.
Let me tell with the activity, maybe activity. Types of question will depend on the question how he is asking. It's depend on the question how he is asking. Like let me show you.
Sir, in 2.4 fourth question.
2.4, I think. See, the case is he made like this. In that case, he is asking. So that is a different.
Non-homogeneous.
Non-homogeneous. In this case, he is asking. So in this case, he is asking only dependent and dependent variable. He is not asking any solution or any kind of thing.
Sir, could you draw the coefficient matrix so that it's a little clear?
Yeah, I will.
So we have to check only coefficient matrix or the augmented matrix?
No, actually, you have to make it in augmented form. From the augmented, it is.
We will have to reduce it into row echelon form.
Reduce row echelon form. From the augmented, because. So as here is here, let's do that. So this is we have a system of linear equation. Let's write the augmented matrix of it. So rest all are 0 in the first row. This is 0. So this is
0 1 0 0 1.
0 1 0 0
1
and 0 0 1 here, I think.
1 again in the augmented.
Okay. So as here, this is if this is not in reduced row, you have to change in reduced row, but it is in reduced row because the lead, as you can see, for the first row this is leading entry. Okay, so now the second row, this is here is leading entry. So these are not leading entry. Now you will work on the whole matrix only. Forget about this one. If you are it's creating problem for you, you can remove that. Otherwise, leave it. You will work on the augmented matrix as the whole matrix, whole augmented matrix. Your matrix, when you wrote your
augmented matrix will be our main matrix to work upon.
You used to work on the whole augmented matrix and change into reduced row echelon form.
Now so this is already in row echelon form, reduced row echelon.
It is already in reduced row echelon form. Now write on variables here. Now decide that which one is independent and dependent from here. Okay,
all are independent.
Not all are.
No. X1 and X4.
X1 and
X4 are independent.
X2 is leading one, X3 for leading one. So these two are independent and rest all are. Sorry, these two are dependent, rest all are independent, means X1 and X4. Now,
which are dependent and which are independent?
Dependent is X2, right? As here
X2 and X3 are dependent.
Dependent, and X4 is here. X4 is independent.
X1 and X4 are independent.
Independent.
What is the reason, sir?
How did we decide that?
Yeah, actually, okay, for X1, if you assume this column, for X1, this is the column, right?
Yes, sir.
For X1, yeah, if you will write here, it may be difficult. You can just write the above of thing. It will be more better. So for X1, this column will work. So for X2, this column will work. For X3, this column. Because when you multiply, you will get like that. That's why I am writing here.
Okay, so in the column,
sir, we decided we just learned that if there is no non-zero entry other than the leading, then it is dependent. It is independent.
That column for X1 column, there is no leading entry. So that would be independent. For X2, it have a leading entry. So that's why S2 is going to be dependent. For X3, yeah, there is a leading entry. That's why X3 is dependent. For X4, there is no leading entry. That's why X4 is independent.
And if there had been other than a leading entry, if there would have been an element which is non-zero, then again it would have become.
Suppose here is one. Suppose here is one. Okay. Suppose here is one, but this is not leading entry. Here for this column, so still it will be independent. X4.
And what about if the 3-1 element becomes 1? It will not be reduced. It will not be a reduced row echelon form. Okay.
3-1. This one.
1-3. Sorry.
1-3. Okay. 1-3. Then 3-1. It will be 3-1. So if it is 3-1, so it is not in reduced. So you have to change. Then decide.
Yes, sir. Yes, sir. Got it. The only we have to only check for the leading entries, and we should make leading entries dependent, and rest of all of them will be independent.
So in this case, so we have 2 independent and 2 dependent. Does that tell us anything about the solution?
It's now what is that? You can go with the solution now. Let's back. This is in reduced row form. Okay. Just change this matrix in system of linear equation. What is that? It will be X2 is equal to 1, right? Rho by
and x3 is equal to 1.
And x3 is equal to 1, and x2 and x1 and x4 are we don't know. So that's why it will work as an independent. So the
why is x3 1?
Here is that you one by one you multiply, right? What you will do? So what is the process that? Just remove this one, right here x1, x2, x3, x4. That is the process writing to be.
Oh, okay, it's augmented. Okay, sorry, my mistake. I didn't realize.
So that's the process. From the matrix, just back to the system of linear equation.
So there were 4 variables, right? I think we're missing a column, right? In the augmented.
No, we are not missing here. All are.
Sir has randomly taken variables.
1, 2, 3, 4. All are here.
Sir, you can write
And
x1, x2,
solution.
x3 as the variables. You have written x4. That's why the confusion is arising in the column matrix on the right hand side.
Okay, x3.
And delete x4.
Oh, there are only 3 variables, right?
Yes, and the last one makes the augmented matrix.
No, there are 4 variables.
There are 4 variables.
4 variables.
Last one is 0, 0.
Hello, sir.
This one is
because not x3.
No, 1, 1. That is 1, 1. Last
0,
one is
0,
1,
and
1.
then the part of the
No,
yeah.
so what
augmented
is
matrix becomes 1, 1.
This is 1, 0, 0, 1. Augmented is 1. 0, 0, 1, 0, 1. This is our matrix. From here, we want to conclude. We want to find the system of linear equation. What is that? How we will conclude? What is the? This is 0 here. Okay, this is it. So what is the system of linear equation?
X2 is equal to 1.
X2 is equal to 1.
And x3 is equal to 1.
Equal to 1. This is the system of linear equation.
Yes.
This is right. From here, this is the system of linear equation.
Yes. And what about x2 and what about x?
So what is that?
x1 and x4.
So
they are
you can
dependent.
write like this, right? 0 x1 plus x2. So it is like so here is x2. Sorry, x1 and x4 are working as independent. As here we got from the reduced Gaussian.
It has not. It has got no constant equals and dependent on no other variables. That's why it is independent.
From here you decided okay, x1 and x4 are independent. You also from the equation you can here conclude that okay, x1 and x4 are independent. From
so
here
we can take any values for x1 and x4.
So yeah, they are working as an independent. So assume x1 is equal to t and x4 is equal to some t prime. They are independently they are working.
It could be a constant as well, sir.
Could be constant.
Sir,
how is x1 is equal
independent
to 1?
okay, it is variable that it cannot be constant. It has to be
sir,
t or
I'm
t prime.
confused now, sir. Sir, what will be the solution for this? I mean, what will be the values for x1 and x4?
So x1 is equal to any real number he can take. X2 is 1 here, x3 is 1 here, x4 is any real value. This is the solution where t1 and t prime belongs to R. So this system of linear equation has infinitely many solutions. Okay.
Sir, we can't just form an equation by x1 and x4 here.
x1 and
they are independent. They are not dependent on.
They are not. See, there is no role is happening. That's why they are working as.
Sir,
both are not related. Both are not related in any way.
Okay, like in previous questions, you have an equation like x1 is equal to c minus 5.
Sir, the fourth question is similar, right? You can say.
That is a similar thing. Like you can conclude from there. Why?
Okay.
No.
Sir, I have a for independent and dependent.
So 12.
A variable not dependent on another variable, then it's independent. No. Like x1 is equal to 1. So it should be independent because it is not dependent on another variable. So I thought x3 and x1 in previous example independent.
Sir, why here in fourth we have no solution?
Sir, if there are 4 variables and one is independent, So that means that will have many solutions.
So it's happening, right? This have many solutions, right?
In a system of linear equation, if there is even one independent variable, then infinitely many solutions.
Infinitely.
What will be the case for no solution?
The case is here is so you need to be a consistent case, means in the system has solution and it have in independent variable. In that case, system has infinitely many solutions. That's
Yes.
the
And what is the case for no solution?
No solution is there is no solution. That's all. Then how we can discuss that?
Asha means for 0 and 1. Okay.
He's asking that by knowing the dependent and
suppose our system of
variable.
linear equation is this one. Okay, let me write it. 0 x1 plus x2 plus 0 x3 plus 0 x4 is equal to 1. Okay, 0 x1 plus 0 x2 plus 0 x3 plus 0 x4 is equal to 1. Suppose somebody is gave this one and asking find the independent variable or find the number of independent variable. Okay, somebody is asked find the number of independent variable. Okay, so what is that? 0 1 0 0, and let's write augmented also 1 here. 0 0 0 0 1 here. Okay, so this is in augmented matrix, and sorry, this is augmented matrix. Change it in reduced row echelon form. So let's change it in a reduced row echelon form, because this
R2 is equal to R2 minus R1.
So this is leading one here. So this is not here 0. So let's make it 1 0 0 0 0 0 and 0 0 0 0
1
0 1 here. Okay. Now this.
Sir, this is in the reduced row echelon form, na?
Now this is in reduced row echelon form.
No, sir.
We just did the operation that R1 is equal to R1 minus R2.
R1 minus R2 I did. This is not in reduced row echelon form because this is leading one here. If you have problem with this, remove this one. Now,
so what is leading? What is leading one here?
Leading one means this much I taught. For this row.
No, sir. I got, but
he is asking that which element is leading one.
Yes.
Leading one. No, so now I will write, right? Now I will write. Let's write here. So we will see that. That's why let me finish this one. There is not this is right side. There is no variable here. So actually what is happening? So let me finish one. So this is x1, x2, x3, x4. Okay. So suppose somebody is asked like this. Your question is here and asked find the
number of solutions.
Not number of, find the number of independent variable. So first thing, he will never ask like that. See, he will, when the system is consistent, then he will surely ask the number of independent variable. So in such cases,
there is no solution.
This system has no solution. You are looking.
No solution.
This system has no solution. So
why it doesn't have any solution?
Because in the second equation.
This is if you make it bar line kind of, this is 0 and this is 1 here. What implies that 0 equal to 1? This is absurdity it implies.
Okay.
So this have no solution. So first thing, he will never ask the independent variable. Suppose he given the matrix of coefficient matrix, in that case he will ask only. So in that case, he will assume this is homogeneous. So he will assume in that case is 0. Somebody is asked like he just given the matrix and said that this is the reduced row echelon form of the coefficient matrix. So he will surely assume right side is 0. Otherwise, in such cases, he will not ask like this question.
Because there will be no solution.
Because this is no solution and there is no mean to say independent and dependent. Only the consistent in the system is consistent, means solution have in that
one
case,
solution or infinitely many solutions. Then only we talk about dependent and independent variable.
In that case, he will ask. So suppose it is like that. So suppose it is like means there is no solution. So let's not discuss one. Otherwise, in that case, in that here is one. In that case, somebody is asked find the number of independent solutions. So he assumed that system is homogeneous. So homogeneous case, either no solution, homogeneous case, unique solution or infinitely many solution, right? In the homogeneous case, either have unique solution or infinitely many solution. That means system is consistent, and in that case, how many variables are here independent? So leading one are independent.
Okay, sir. Here I think x2 will be 0, and except x2, all variables will have some.
All are
Yes. 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 Yes, sir.
So clear?
Hello, sir.
Yes.
Clear,
Question number 12. Yes, sir.
Okay, let's.
Sir, I have just one question. When we have the augmented matrix, even the column, which is augmented, has to be in reduced row echelon form, right? Even that has to be reduced. Even that would be considered as a leading entry.
So in that case, yeah, that is considered to be leading entry. But when we will in final thing, means when you deduce the system, that would work as a leading entry. Okay, if you are confused,
Okay.
that will work as a leading entry.
Okay.
But finally, when you find the system of linear equation, do accordingly and decide that. That's the main.
Okay.
12 questions, sir.
Let's discuss now activity. Almost I have discussed the reduced.
Sir, question number 12.
Okay. Question number 12 in this.
No, sir. Solve with that. Solve with that.
Can you take 2.3 activity? Firstly, we will finish activity, then you can go with solve with another.
So just to clarify, means when we are reducing it to reduced row echelon form, we have to take the augmented. When we are taking the augmented matrix, B column should also be in reduced row echelon.
B column also work as you need to work as this leading entry will come. All things are whatever. Let me go with this raising hand. Let me go with the raise hand. Biswajit.
Yes, sir. Sir, actually, I didn't get some point from the lectures.
So where is that?
Sir, I think it is 2.3.
2.3. Okay.
From 19 minutes 58 seconds.
Okay. 19.
Yes.
Okay.
Sir, I didn't get that point. So can you please just explicitly.
So
Yes.
means what? Educate and inverse. So what is sir is trying to find? That AIJ, CIJ, determinant of A. Okay. One. If A is in cross matrix, then A inverse exists and equal. Okay, so he is trying to prove. I think so.
Yes, sir. Yes, sir. He's trying to just prove that. Prove the entries of the new A inverse matrix.
And A inverse is equal to exactly adjoint of A upon determinant of A.
Yes, sir. Okay. Sir, at this point, he explained that. Sir, this point I didn't get. A into sir. Is the
first which number which?
Sir,
which
in
line?
the second last step, I understood. Right after that, I could not. So please, from the last step itself.
Okay. After all.
Yes, sir. The IIth term of that matrix is 1. But does that mean how did he just derive it from that previous previous term?
Okay, just okay.
Sir, will be discussing any new concept in this session, sir?
No, not new. This is not new. This is just he had doubt with the lecture itself. How sir is getting this, and that's it.
Yes. Sir.
Okay.
Sir, can we have one additional session, sir? Rather than we have it on Tuesday, intermediately Monday, can we have one?
Sir, actually, here he is multiplying the A matrix with the adjugate matrix, and after multiplying it, if it is the inverse of that matrix, then we should get an identity matrix. So in that identity matrix, the every ith term will be 1.
Identity means every ith term will be 1.
Yes, I have got that point, but the way he solved for the all other entries except ith term will become 0, na? So I didn't just get that point.
Okay.
Can you just play? Then he.
Just 1 minute. This is okay. Cij determinant Cij. Okay, this is one here. Okay, this is Cij. Okay, Aij.
This is Ji adjugate.
This is
the Ji. Yes.
Okay. Now from here we just this is Ji and this is Ii.
Yes.
Okay. Now what is doing? Okay. And here is if I not equal to this become 0. Okay, so actually see this is one property. Okay, actually, but
sir, we are just simply just multiplying here, man.
Actually,
we are taking I as a constant, and J, the summation of J will be applicable. Means we are just multiplying the first row of A with the first column of that matrix, 1 by determinant of A into adjugate of A. And just like that, we will multiply the second row of A with the second column of matrix. Second column. So, I'm a bit confused here.
Actually, let me. Actually, this is whatever sir is doing here. Actually, this is a property, but I am not. See, the thing is A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, suppose you have a matrix. So for this entry, what is the minor?
A22, A23, A33 minus A32, A23.
A32, A33. Okay. Now, for when you do the determinant, when you minus means this is the determinant of this. Now
A22 minus A223 into 833 minus A23 into 832
into minus 1 to the power I plus J.
No, that is not minor. That is cofactor.
That is cofactor.
Cofactor will be here.
Transpose of the cofactor matrix.
Aij minus 1 raised to the power Aij.
Minus Aij. Sorry, I plus J.
I plus J.
And with the minor determinant with the minor.
Yes, sir.
Okay. So now see the properties. See, when you do this, it will be like for this one, it will be plus. So determinant of exactly for this entry, the cofactor is determinant of this matrix.
Positive. For the first element.
Positive. Now this is one property for that. Actually, this is actually what is doing, sir. This is a property that when you multiply, suppose this is your entry. With this entry, you will multiply with this minor, means cofactor. Sorry, cofactor. So it gives 0. When you add those all, see what it mean to say. Multiply this, sorry, A21 with rest all any mean to say for this.
If it is not if it's on cofactor, then it will bear 0.
If this is not a cofactor of that particular, different from that.
If it is a cofactor of different element, then it will bear 0.
It will, when you then if you sum it, it will give 0. That's the thing is happening here. And that's the here mean also, like Aij with the different. That's why if Aij different Aij, if you are multiplying with
sir, Sir, please come from the, beginning of that equation.
Actually, for that, okay. I have to watch first this properly, and then
yes, sir.
I post it properly in the discourse? Exactly this one with the
or we can discuss in the next session. We can keep it for the next session.
No, next is solve with us. I don't think it will be possible.
So I will post in
Discourse will be the best
form.
Yeah.
Yes, sir.
Why this
sir,
is
please, sir, do it. In the discourse.
Maybe a video, sir.
Again, I think it's
because
not possible.
Properly,
Because
I will write the reason why this is 0. I will write properly and
better.
Yes, sir, step by step, because I am not getting even the second part to third part.
I have noted it one. I have noted. I will actually, I didn't see this proof. I know different proof, maybe, or maybe this time after recalling this one, I have just noted this, and I will write exactly one by one whatever the sir is doing.
Yes,
sir, you can also post alternate proof that the one you know.
Otherwise, I will also post my proof also.
Okay, sir.
Sir, one more thing, one request. When we have one intermediate session for week 2, we have on Tuesday, but Monday there is a possibility. One more additional session.
I don't know. I have to ask our committee or operation team.
Because to be very frank, the week 2 I am not covered fully.
Okay. I will ask the committee. Then they will decide.
Okay, if possible, please consider.
Yeah.
No, sir.
Okay.
Sir, I have doubt in 2.3 only. Can I ask?
Let me go with the Santosh.
Okay, sure.
Santosh.
Sir. Hello, sir. Sir, question number 12. Solve with us 2.2.
2.2.
Solve with us.
There is 2 solve with us, so you have to go down.
Second solve with.
Second solve with us.
So we will be discussing in solve with us in the solve with us session, no?
Sure, probably. I'm not sure.
Not all the questions.
Not all the question,
Yeah. There are only selected
Only this
questions
question related
from
to
the activity as
augmented
well.
matrix.
Solve with us means we are not going to discuss this one. Solve.
Yeah.
Solve
Just some selected question from activity and other stuff as well.
Or maybe
from practice assignment
somewhere, and you will solve with us. We will give you the question, you will solve, and then after some time we will solve. Like as previous one.
Yeah.
Question number 12.
Question number 2, okay.
12, sir. 1, 2. 12.
Okay. What is out here? What will be the RC obtained by?
Reduce echelon form. Sir, option is saying last. Yeah, that is the option.
So that is the answer. You maybe.
Yeah, that is the option, sir. But in that option, if you see last row 0, 0, 0, 2. So is it possible, sir? I think it should
leading
be
leading edge is not 1 there.
Yeah.
Okay, just a minute. What will be the matrix obtained by performing operation? Let us from A to reduce echelon from R on the augmented matrix. Okay.
Yeah.
Actually, this question is asking for the R is in augmented matrix. So this is our R, right? This is a C. Okay, no matter. C is not here, but R is in augmented matrix.
So he's only asking about coefficient matrix.
Only R is in augmented matrix.
Okay. It is only asking about coefficient.
Not whole. Only for
not
this
whole.
R. This R.
Okay. That's why.
Okay. That's why many of you got confusion about this one. No, actually, you will do the whole operation. You will change the whole augmented matrix in reduced row, and then find the solution. Yeah, it is a particular case for asking for R, not for the whole. Yeah, that's the okay. Maybe you got because of that confusion.
So we have to do elementary row operations from the given linear equation. Then come to the conclusion.
Okay, so next is Ayush.
It's the fourth question of activity 2.3, if you can see.
2.3. Fourth.
It's the last option. Fourth. It's the last option.
Adjoint have a solution.
Yeah.
So what is the problem here from? Why you are not able to solve, or what is how much you solve?
Sir, I just not able to solve it.
See, this system. You have this system of linear equation, and set A is invertible.
Yeah.
What
So
mean that?
So it means that inverse exists for A.
Inverse exists.
Determinant of A is not equal to.
Determinant of A is inverse.
Yeah, so inverse exists and determinant is not equal to 0.
Not equal to 0. So okay, let's see that. A is invertible means A inverse is equal to adjoint of A upon determinant.
Yes,
This
sir.
is right.
Yes, sir. Yeah.
So as A is invertible, means determinant of A is non-zero, or you can say determinant of A inverse is also non-zero. That's the mean.
Yeah, same thing.
So what it means that actually this system, this question asking for this solution.
This solution, yeah.
Adjoint of that.
Yeah.
So how you will conclude that if this determinant is non-zero, what it means that it have unique solution, means it is invertible.
Yeah, this is
how we will conclude this is invertible. So see, this is if you take the determinant of both sides, what it says, it's a determinant of the whole adjoint, one determinant of A. And whatever the degree of whatever the order of A, it will be come to as a power, let's say n is there, so it will be like that. Determinant means the determinant will be 1 upon determinant to the power n and determinant of adjoint. This will happen, right?
Yeah.
So what it says is this is non-zero. Determinant of adjoint is non-zero because this is non-zero. This is non-zero.
Yeah.
What it means that adjoint is inversible. Non-zero means determinant.
Yeah.
So it means adjoint is inversible. So in that case, solution is exist or not? Exist.
It will exist. Yeah.
Means it has solution.
Yeah.
That's all.
Yeah. Thank you, sir. Got it.
Everyone getting this one? What I'm saying means we want to conclude determinant of adjoints is non-zero or not. Non-zero means inversible. So
we can take some value for determinant of A and then we can prove as well.
You can prove as this is saying to be any number.
Yeah. We can take number, or let's take we can take some variable as well, like A, B, whatever.
Mean parameter, that is called parameter.
Any parameter. Yeah.
And then next is, let me see, I use Bhanu Pratap.
Yes. Sir, activity question C 2.1, question number 4.
2.1.
1. Yes.
Question number 4. Okay.
After solving this matrix A for determinants, I got some A cube, B cube like this. So how can I conclude that? How can I use this A plus B plus C is equal to, for example, 6n?
You got, what is the determinant you got?
I got A, B, C minus A cube minus B cube minus C.
A, B, C minus A cube plus B cube plus C cube.
Not both are minus. Minus B cube minus C.
It will be like that. Okay, so this is the determinant of that.
And I am assuming A plus B plus C is equal to 6n.
So if you from here, then it will be difficult to determine. So actually that's the purpose is given here for how you will apply row operation when you do the row operation of type 1, type 2, type 3. Means
Yes, I also tried it when I apply row operation, like adding R1 plus R2 plus R3, then A plus B plus C. And if I apply same rule in R2, then it's also A plus B plus C. Also in
and then we can
R3.
take common.
Yes, and then we can take common, but the matrix will become 1 1 1 1 1 1 1.
So it will be like A plus B plus C, and then 1 1 1, rest are whatever.
Yeah.
Right?
Exactly.
Right.
What it mean that determinant of that matrix is determinant
multiple of A
plus B plus C.
That's the happening. Multiple of A plus B in determinant of this means determinant of A is multiple of A plus B plus C.
Plus C, correct.
But determinant of 1 1 1 1 1 1 1 1 1
whatever will come, no matter
whatever will come, it
no
will
matter.
be
But yeah, it is
multiple of A plus B plus C.
B plus C now.
Whatever, it's only 0, not another thing.
So he is saying that all elements of a matrix or determinant is 1, then the value of determinant will be 0.
All is 0 means all
but
are
he is wrong, no?
Then you may wrong.
Yeah.
Because all are may not be 1.
Why not? Because
let's do that. Okay, it is confusing.
If all are 1, then it will be A plus B plus C ka whole cube.
If you are okay, let's see that. Okay, we have this one.
Still it will be a multiple of A plus B plus C.
It still
doesn't make any difference. Whatever it will come, it will be a multiple of A plus B plus C.
I think your assumption is then it is divisible 5 by 5 also, na? You are getting this because determinant is 0.
Determinant of this whole thing becomes 0. That's why I'm doing.
Actually, see, it will be not 0 as because just now you said we got determinant A, B, C minus this one. You got determinant is this as according
in this way it is not 0. But when
so
I apply
that
this
means you are making mistake here. You are making mistake here first, and now
I could not figure out what the mistake is.
It cannot be 0.
So that means it cannot be 0.
But why it is becoming like a 0?
It's looking like a 0, but it is not 0. But the thing is, it is coming to as a multiple of A plus B plus C.
That is our
interest. Will be our answer. That is our main here.
Yeah.
Whatever the now it is, you got that. Okay, this matrix will give never determinant as a 0. Whatever number will come, but that number is
multiple of A plus B plus C.
Multiply with this number also, and this will the whole determinant of this.
And it is given that A plus B plus C is equal to 6.
So that's are you getting?
No.
So the answer will be B, 3, D, na? 6, 2, and 3. Because 6 is multiple of 2 and 3 as well.
5 is not a.
5 is not the answer.
If determinant of this is not 0, then answer is correct. But I am confusing in when I applying this rule R1 plus R2 plus R3 for R1 and same
so actually from R2. Here you are getting you are saying determinant
R1 plus R2 plus R3 is not possible. Na? You can add 2 rows to a 1 row. Not all rows you can add together. I guess you are doing that sort of elementary row operation error.
Yes, this kind of thing. And I'm thinking about why am I wrong. Why can't we add 3 rows?
Because it is not possible. It is not the rule, na?
Actually, see, you can do like this: R1 plus R2 plus R3. Means you are changing as what it means. If you
R1, you are adding R2 and R3 in R1.
R1, yeah, that's the mean. So it will be A plus B plus C, A plus B plus C, A plus B plus C, and rest is B, C, A. I think. What is that? Let me write that.
CAB.
This is the next step. And
then we take A plus B plus C as common.
Now ABC is now A plus B plus C common. So it will be 1, 1, 1.
1, BCA.
CA.
CAB.
AB. Next step is if you want to find the determinant of it, make it easier somewhat. So how you will do? Just see, you can do the row operation or you can do the column operation to make it as a 0 here. Means I mean to say
column 2 is equal to column 2 minus column 1, and column 3 is equal to column 3 minus column 1. This is where 0 0.
Column operation I don't aware about.
So no matter. So just expand now it. Now expand it here 1. So it will be BC
CB minus A square.
A square minus 1 here. So it will be B square minus CA and plus 1. Okay, this is, so final thing is you are getting this one. Okay, let me write. Okay, this AB minus C square. So this is multiply with ABC also, right? ABC.
Oh, okay.
Because it is A plus B plus C.
Now I am getting. Yes, I get.
Whatever it is a multiple of A plus B plus C.
Yes. Now I get. Thank you.
Now any of your doubt, or it's now 5 reaches to 5? I don't know. Many of you got, or concept is clear or not?
Except that you know, adjoint question, I guess everything we discussed is crystal clear.
Yeah. Informing.
Except the adjoint. No, okay. That will I will write. That will I will write into.
Sir. Actually, so when that, can you please go to the question, like after solving this only we will come to know that if it is a factor of 6, then only we can say it is a it is divisible by 2 and 3, or is there any alternate without calculating this determinant we cannot conclude that one?
It will be difficult because when you reaches to here like that he is doing, so from here it is difficult to conclude. So you have to be like very sharply, you have to do like that, then it may.
We cannot do guesswork.
Now, but sir, now you may say that A plus B plus C will be a multiple of that matrix. But now, how do we come to know that if it now it is it means that it is divisible by 6? A plus B plus C. I just do not get actually. How did we conclude?
It is given in the question that A plus B plus C is equal to 6.
Divisible by 6.
It is given in the question.
It is given that it is divisible by 6. It is not 6.
It is divisible by 6.
So it hardly matters. Okay. It is x times 6 or 6. X is equal to 1.
But the statement should be correct, na?
So okay, sir. Then A plus B plus C is divisible by 6. So once we come to know that it is a multiple of A plus B plus C, then we can say 2. It is divisible by 2 and 3 and 6
and 6. Yes.
Okay. Thank you, sir.
Okay, so somebody said 2 point. Okay, otherwise, yeah. Or he gave the best thing also. Sathe Anand he given. See, yeah, this is true for. See, this is a good thing. In chat, you can see. This is given as a general matrix with this kind of thing. So, see, this is the very good thing. See, you want to eliminate this. So you can assume A plus B plus C like that. That's make it sum 6 and put the numbers here and do the find the determinant like that. You can do. I can decide. Okay, this is happening.
Yes, this is how I also.
That is also very good thing. Like this is, I used to try also many times. See, whenever there is a general
take some value equal to 6.
So following that, give us random value, applying that condition, and do the thing.
Just put in the elements of the matrix.
But we can't be too sure about taking any random value.
Every time. Multiple of 6.
Just talking about every time, we can't be too sure about it.
It should be. It should work because the condition is given.
Yeah, mostly it should work.
Random value is one value of the generalized.
Because this matrix
so we can take it.
It will work. It will work because
but that one random value can be can have other characteristics also, but you can't say that it will be applicable for all the values. You know, you can't prove with just one.
But in the given case, we can take it.
Yeah, in given case, yeah, that's what I'm saying.
Actually,
it's working, but we can't say every time that we can take.
It would not be a rule in general for every time we do it. But in the given case, we can solve the question.
Every time.
Yeah,
you can't take every time.
Yeah, actually, this mean to say proof. You cannot do.
Yeah.
Somebody's asked like a proof, then you cannot say like that. Yeah, but eliminating the option you can do.
Yeah.
So this Tuesday session, can you please think over Monday session?
Okay. I will ask only. Okay, I will ask. They will decide. Okay?
Yeah. No issues. But just put full, sir, at least.
Yeah, I will ask.
Okay.
Thank you so much.
Thank you, sir.
So let's end the session.
Thank you.
Yes, sir.
Yes, sir.
It was very long and very beautiful session. Thank you so much.
Yes, sir. Very helpful session. Very kind of you.
Hello, sir. Sir, in Gauss elimination method, we have to reduce all row in row echelon form, or only we have to reduce a coefficient matrix into row echelon form, reduce row echelon form.
Augmented matrix will be reduced in row echelon form.
But professor said that we have to only coefficient matrix have to in row echelon.
So that case is for homogeneous. Sir have clearly, I think so, said also. For the case of homogeneous.
In Gauss
for homogeneous, the last column is automatically 0, 0, 0.
Last column will be automatically 0. That's why the coefficient, you need to work on coefficient matrix.
In homogeneous we have to.
In homogeneous you have. Otherwise, non-homogeneous, you have to make augmented and then decide.
Okay.
Thank you so much. Let's end the session. It's now 3-hour session. Okay.
Thank you, sir. Thank you very much.
Thank you very much, sir.
Yeah. Thank you. Bye.
Hello. Is there any problem? Please respond somebody.